Okay. Hello. Hello. Starting a little bit later than intended, had some technical difficulties because, as I'm sure you know, computers exist. But it's fine. I win. Here we are, part 20, amazingly, of this seemingly never-ending attempt to make a WebAssembly interpreter in Ruby. And why am I doing that, I hear you ask? And to that I answer, well, it's mainly so that I can have fun. It's partly in order to demystify WebAssembly for myself, because I've never really used it. And it's also to share how I do it, in case you're interested, which I would understand if you're not. Reminders from me. It's more important that I have fun doing this than that I make a fully functional WebAssembly implementation. So I'm, going to try and keep things in perspective. I want to write correct code. I want to write clear code, even if that means that the code's a bit slow and the code's not very clever. I'm fine with that. And I'm trying to do it in pure Ruby, and I'm trying to resist the temptation to use any dependencies. So before I get stuck in, quick retro on what happened last time, which I am just now remembering. Last time. Yeah, okay. So last time was a bit of a slog. At the beginning of the last stream, I was very kind of, in my previous retro, I was very sort of optimistic and happy, and I was saying, I was happy with progress, and I unblocked 7 tests in one session, and I'd really got ahead of steam, and I was really making progress. That immediately, my hubris immediately angered the gods of productivity, and I spent the whole stream slogging through a pretty tedious piece of busy work, if I'm honest. But the upside is that at least that's done now. I have now extracted the remaining bits of the parser from the interpreter. So I don't have to deal with that sort of half-finished transition anymore. So that's really good. And of course, I did actually flush out some sort of latent bugs. It turned out that my parser actually didn't work properly, and I didn't know about that. So now I do know about that, and I've fleshed it out, and I've sort of dealt with that problem. So I think things could have been worse, but it wasn't, it wasn't the most fun thing to work on, is what I'm trying to say. So yeah, I don't know. I mean, what have I learned from that? I don't know. I just didn't enjoy it. That's all I'm saying. I just didn't enjoy it. So, let's not dwell on that. I'm going to dwell on it a little bit. Worthwhile chore or not, I do need to tend to my motivation, like I feel slightly not defeated, but like I feel a bit ground down by how long a task that was and how sort of fundamentally uninteresting it was. It was fairly mechanical. So for now, I think I'm going to try and do something else, at least for a bit. I'm going to do the thing that really makes me feel like I'm making progress, which is pick up a test and make it pass, just to make myself feel like I've still got some of that momentum from the previous stream where I got 7 of those files working. And I mean, I do enjoy extracting and refactoring and cleaning up and stuff, but I think on a project like this, that has to be balanced out with things that feel like forward progress. Otherwise, you just sort of slowly lose the will to live, and it sort of, it feels like you're treading water, and then you're treading water less and less enthusiastically over time, and then you just sort of gradually sink beneath the waves, never to be seen again. So I don't want to get myself into that situation. I like being alive. So hopefully this next hour or so, he says, hopefully that'll be something different. I'm just going to pick up an instruction I haven't implemented before. I'm going to look at some of the failures and troubleshoot them, I mean, the problem is that does mean having to continue to punt on the identifier context that I've already been putting off for weeks. But I'm only human, and I think if I try to do that today, then that's just going to sap my last. Well, I don't know, not necessarily, but I just want to tread carefully with respect to my motivation. Like, I want to make sure that I'm getting a little bit of, well, motivation, basically. However, in last stream's Slog of War, I did make quite a big mess of the AST parser, which is already quite hard to read, and I fear it's going to be even harder to maintain in future, which I'm going to have to do as I add more syntax. Like everything has to go through the AST parser. It's a fundamental piece of the front end. So I think once I've rebuilt my stamina and my motivation, I would also like to step back in there for a bit while I still remember how it works and what it's doing, and just sort of tidy things up a bit. And my hope is that it will be more therapeutic than frustrating, because it's not quite so mechanical and tedious as what I was doing last time. When you're refactoring in peacetime, when you're not halfway through some kind of hairy transition, which is where I was last time, and it gets a little bit stressful, and I feel like I have to just do whatever it takes to make progress. But when when the progress is made and the tests are passing and things are broadly in the places you want them to be, I think it can be an opportunity to sort of exercise judgment and have taste and make interesting decisions rather than just being a sort of tippy-tappy code robot, which is what I felt like I was last time. So, end of retro. What do I need to press? I think I need to press this. Yes, that's a thing. And now I need to press this. I do actually have to press things to make this happen. I know it seems like magic, but it's just computers. So, as usual, where are we? As usual, some tests are passing. That's the situation. This plan for the next stream section has just become it's just become a laughing stock, because this is just where I'm scribbling notes now. All right, well, look, I'm knowingly going to deprioritize the identifier context, because even though it is quite pressing, I feel like I need a bit of cool down before I go and add more features to the AST parser, because I spent literally 6 hours on it last time. Nested comments. Well, I'm going to say it's not super important, but maybe that's the thing I choose to work on. Okay, this was the one thing I did achieve last time, parse the function body once at definition time, so I've done that. I don't know why I checked this. Should there be an expression AST node that's returned from parse expression? If not, should we get rid of script? Yeah, I think that was erroneously checked. I mean, I honestly can't remember what I did last time. In my delirium, I might have just said I'm not gonna fix that, but I don't think I have fixed it. Do we really need terminated by in AST parser? It seems like you can just use with input to set the input to as much or as little of the input as you actually want. Or is the problem finding how much you want? Can read until always just do that for you? Again, that's checked, but there's no answer here. So I think, well, I should watch the video back and find out when and why I checked those. But for now, I'm not sure. Right now, I don't know the answer to that, and the answer to that is not written in this. So if I thought I knew the answer to that, I should have written it down there, because I don't see any answer. Oh yeah, okay. Yeah, so this is more in the refactoring. So this is stuff I can do when I'm refactoring later. I think this is a good point. I think you should be able to... There's currently a bit of a mismatch of... Well, sort of an impedance mismatch between the semantics of some of these methods. So when you look at the ones that I implemented initially, so things like parse normal instruction, what that means is I know that the very next thing that I'm about to read is a normal instruction, which is one of these like non-structured and also non-numeric instructions. So something like return or no op or whatever. And the first thing it does is reads that instruction. It reads the first, the opcode, essentially, the name of that instruction. And you can see in parse structured instruction, again, the first thing it does is read the opcode. And in read numeric instruction, that is also the first thing it does. So you don't call these things having already read that, we just peek. And then on the basis of that peek, we call into these parse methods and they deal with actually consuming that opcode. In large part because they need to know what it is. So if we consume it up here, because these are implementations of more than one instruction, if we read it here, then we'd have to pass it in as an argument, which is silly. But because of the way this sort of organically evolved, I've ended up in a situation where you can see it's sort of been turned on its head, where here parse command is reading the opcode, and then it calls down into, as it so happens, each of these has been sliced thinly enough that actually these each corresponds to exactly one opcode. So that's how this has happened, is that in practice, these methods don't need to read the opcode because they will only have been called if the opcode was module or invoke or assert return. So it's not like a serious problem. It's just one more thing to have to remember, that some of these parse underscore methods, when you call them, are expecting the opcode to still be left on the input for them to consume, and others expect the opcode to have already been consumed, and that's just a completely pointless difference. So that's the kind of thing that I should just go through and sort it out. And okay, identifier context. Don't worry, I remember. Oh yeah, we fixed that last time, that if else situation. Okay, well this is what I was actually looking for, but this seems fine. I'm just going to say here, like, pick a test, make it pass. Oh look, we did this. This should be checked. Support parsing modules, function definitions, etc. That was... Why didn't I check that last time? That was totally a thing I should have done. And then you've got all these stretch goals. The data with refinement, kicking the tires on YJIT, Chris Zetta's PR, which I didn't get a chance to look at last time. I don't know if I'm going to get a chance to look at it this time. Sorry, Chris. I will get to it, but only when it sort of when it fits. And yeah, writing a contribution guide, which is not even code, is it? But nonetheless, I sort of, well, this is a little bit meta. I think one of the things I want to put in this contributing.md is, I've sort of thought about this a little bit, and I feel like really the primary output of this whole project is these videos, and I want to sort of, I think it is currently true that every single line of code in that Git repo, or every single line of text in that Git repo, has been written on live on this stream, and a video exists of me writing it. And so I think maybe I want to maintain that streak. And so that's why I would bother writing this file on the stream rather than just doing it offline, because, well, and I think what this file is going to say is that I want every line of code to have been written by me on the stream. And so by its own, this is a little bit self-referential, by its own assertion, I need to actually write it here rather than just do it in private. Anyway, pick a test, make it pass. That's what we're going to do to get started. And like I say, hopefully this is going to be slightly rejuvenating with respect to my motivation. I mean, it's a little bit frightening scrolling this file and seeing just how many, like, undone things there are here. I mean, all of these are sort of, by definition, minor fixes. Maybe sometime soon I should have, like, a fire break and just stop trying to make forward progress and just try and blitz this whole list. And because I think all of them, I would hope that almost all of them are just like a 5-minute job. Oh, look, I've done this one. Only call unfold on folded instructions if possible. This was a thing that I was. Oh yeah, remove else expression from unfold if this happens. See, like I completely predicted not only this problem but also the thing that I was going to have to do at the end of it. I completely forgot this was here, but that's done. I did that last time. Anyway, what I was saying was I think these will all be little jobs. Not all of them, but I think there's sort of an 80-20 thing here, which you can interpret in whatever way supports the point I'm trying to make. Anyway, yeah, I'm just conscious that look at the size of that scroll bar. Like, there are a lot of little snags in here. I would feel much more relaxed if every single one of these was either done or like won't fix. I'm not going to bother. But right now they just represent thoughts I haven't thunk. Okay. Well, maybe I will look at, given that it's a bullet point up here, implement nested expressions in the S expression parser. Oh, it's a bit parsy though, isn't it? Maybe I'll try block. Oh, that's also a bit parsy. It says needs block type with parameters. Which of these looks most appealing? Memory.grow maybe? That feels like something I could just do. Have I already run nop.wast? Yeah, I must have done. Right. So what does that look like? Let me get a browser up here. GitHub.com assembly spec. Nop.wast. As you will see, I opted out of the... Oh, I must have done it on the stream. Opted out of the beta of the file browsing thingamy. Because I didn't like it. Because I don't like change. The way things already work is the best way. So I assume this has got a memory.grow. Yes. And which test is failing? As memory grow everywhere. Local get nop memory.grow. Expected 3 got 1. I'd like to understand why it's only failing at this point. I would expect... So memory.grow returns the previous size of the memory, I think. And right now, I think the implementation of... if we go into the interpreter, I think the... Oh, I guess it's this now. Right, so we do the right thing with respect to stack discipline, so that's fine. We pop off the delta and we push the current size, which I think is what this is supposed to return, but we haven't actually grown the memory, which is what that's saying. So I would expect the first one to pass, but why isn't this second one failing? Because if assuming it's calling these in sequence, which is what this failure would suggest, expected 3, I assume it's like calling this and then this and then this and expecting to get 3 back here. But then isn't it expecting to get 2 back here? Let's see. Memory grow first, expecting to get 1. Grow last, expecting to get 1. Grow everywhere, expecting to get 3. Okay. Well, I'm not sure that I understand that. I don't get why this should return 1. Grow last. Does it call it with a different... So it calls it with 0, calls it with 2, calls it with 12. What difference does that make? None, really. Oh, hold on. Okay, hold on. So that's the delta, so the delta is 1. Sorry, the delta is 0. Okay, so that first time the delta is 0. Okay. Right. Yes, sorry, I was just being slow. So of course this doesn't this doesn't always have the same effect on the memory size. It depends on the value that's on the stack, right? So in this case, we say grow the memory by 0. So not only does this return the correct answer the first time around, it actually returns the right answer the second time around, because the right answer is 0 plus what this is going to return anyway. So it's only on the third call, where it was supposed to have been increased by 2, that this blows up. Okay. So I think this is all in terms of pages, right? Because when we declare the memory, we declare it to have a single page. So I think the initial size is supposed to be 1. Yes. And then when it's grown by 2, the size is 3. So I can just sort of see that that is how many memory pages it is. I assume that this has to be a positive delta. Yes, because it's called grow. So we don't have to worry about... I mean, I assume... I'm assuming a lot here, but I think these are sensible assumptions. I think there were some tests that checked that when we initialize some memory, it's initially filled with zeros. So I think it's fair to assume that when you grow the memory, that grown memory gets filled with zeros. So I'm tempted to just sort of add another method here called grow. I'm just pausing to think about what I want the argument to be. I mean, here, these are just implicitly in pages. You know, minimum size and maximum size are measured in pages. So maybe I should just call this delta, or should I call it pages? Maybe I'll call it delta, because that appears to be what the spec has called it. So given that no brilliant name for that argument immediately springs to mind, I'll just call it delta. So I think this is going to be something like, I mean, basically we're going to do this. We're going to make some 0 bytes. But this time, instead of the minimum size, it's going to be delta times bytes per page. So this is the extra storage. And then I'm just going to do self.bytes. I mean, I should inline this so that I'm not shadowing the attribute with a local variable, and then I don't need to say self. So bytes is the operator precedence right there. Let's see. What was it? Yeah, that's fine. Okay, I'll just leave it like that, just because then it looks the same as that. All right, so given that, oh, and also we need to return the previous size. So I need to return size in pages here, but then I need to sort of do this on my way out the door. So this primarily returns the size in pages, and then it just so happens to also modify that size on the way out. So I think that's it. And then I think this just needs to call. Oh, actually, I don't need to do that, do I? I can just grow it, because I'm in control of the order of operations here. So the API of this thing does not have to match the semantics of that instruction, because the instruction has an implementation that can do whatever I want it to do. So I think I'm sort of happier with this just being the obvious implementation of this. And then we just manage, well, basically I can just grow the memory after I've pushed the previous size onto the stack, and then it's all fine. So I can just say memory grow delta. Just trying to think if I want to call this something other than grow. I think it's fine. It's sort of tempting to call it like grow by. Yeah, I am going to do that because delta is not necessarily meaningful. Like when I see delta, that suggests something to me, but for someone else, they might just be like, well, that's just a Greek letter. What's that? I think what I'm going to do is call this pages now. Now that the reason I called it delta was because I wanted to suggest the idea of it growing by an amount rather than to a particular size. But now that it's called grow by, I think it's nicer to call this pages, which means this has to be pages. So that's maybe a little bit, now I'm deviating from the nouns used in the spec, but I mean, this is not, the purpose of this project is not simply to type in the WebAssembly spec, it's for me to sort of interpret that specification as I see fit. And so I'm going to allow myself the luxury of just picking my own local variable names, if that's all right with you. So let's see. Right, great. Hey, there we go. There's the dopamine kicking in. All right. Good times. Okay, so let's add this. Implement memory grow by to increase the size of the memory. And then here I will say actually grow the memory in the memory.grow implementation, because I believe we already had a begin implementing the memory grow instruction. I will say, given that I chose to call the method grow by, I've decided that naming its argument delta is both obscure and redundant. So I've just gone with pages instead to make it clear that this is a quantity of pages versus bytes or anything else. Okie doke. Oh, and so, oh, I didn't have NOP on my pending list. I don't believe. No. But I will now. What am I doing? I will now add it. Well, let's just let it run. This is, what do I normally say? Add nop.wast to passing tests. All this needed was a working implementation of memory.grow, which we now have. Okay, and indeed all those tests are passing. So great. All right, chalk up another one. Very good. Let's get rid of it. All right, I think that has given me enough motivation to tackle one of these other things. It kind of bothers me that I haven't written anything for these two. So although it seems unlikely to me that I'll want to tackle either of these, I do at least want to briefly see what their major malfunction is. Ugh. Okay, something bad is happening with the parser there. Sig1. I mean, this is some new instruction that we're not unfolding properly is what this cryptic output means to me, because it's unfolded something in such a way that we've ended up with an identifier in instruction position, and that can only have happened because it's an unrecognized instruction in the unfolding, he says. So what is this $sig1? I mean, I think that we support this. So it's not necessarily this one. It could be some other occurrence of sig1. Oh, well, I've only got two to choose from. Do I... Okay, hold on. Let's look at this. Let's look at this briefly, because this is silly. This shouldn't be causing a problem. So maybe I can... Or at least I'll knock this one down, and then we'll see if there's a more serious... If there's just an instruction I haven't implemented, then fine. But, like, to fail at parsing this is naff. All right, so it's actually quite nice that I know where this is. It's in the AST parser. So what are we doing? We're parsing a module. So let's look inside parse module. And now it's not a binary module. Func memory, table, global, type. Okay, so there is a problem here. Well, why is this a problem? No, maybe it's the other one, because this is already, we already anticipate this, so there must be other code that uses this. So let's just assume that it's this one, this func. Let's look at parse function. Export param, result, local. Yeah, there's no, we don't know about this. What can it be? I think I'm at the point now where, you know, initially, when I didn't have any infrastructure at all, it was very tempting to do the bare minimum. So, you know, if I'd seen this, I would have been like, well, we've just got to parse result on its own in brackets. And then when I saw this, I'd be like, oh, okay, we've got to parse result and then the name of a type. And then when I see this, I would go back and make another change that was like, oh, there actually have to be multiple of these. And I think that kind of made sense early on, because I didn't have any way to deal with any of those situations, and it was quite a lot of work to spin up something. So it was very much a sort of, you're not going to need it approach, just do what I directly needed. But now I sort of feel like if I keep doing that, I'm just making work for myself, because, you know, if I know, so the reason I'm talking about this is like, is this this ID here, is that optional, or is it mandatory, or is it like var args, you know, can you have 5 of these things? Like, and I think if I could just find out now and just set it up that way, then I won't have to mess with it again. So I can see here that it doesn't have to be, well, I mean, this is always the case. It doesn't have to be an ID. This is just, it's just yet another index, right? That's going to evaporate when I get this fabled identifier context sorted out. Right, look, so it can be, it's not just, yeah, okay, let's find out what it is. But clearly, this is, it's more than just type followed by an identifier, or type followed by an index, I should say, either an identifier or a number. There's also, I mean, this is a function type, I suppose. I don't really know what type is doing here. Like, what does this mean? Oh, of course, I'm sorry. I'm pointing something out that was already here, but it's not it's not just this. There's also this. So maybe it's, hold on. I'm sorry, I've confused myself. there are two different things going on here, right? Like this is defining some kind of type, I think, because it's at the top level. But I think this is probably referring to that definition. So I've got to keep my head straight here, because although these look similar, I think they're different. Obviously, references to a thing that's been defined are different than the definition itself. So yeah, that's a type definition. I mean, these, for now, I mean, if I'm right about that what this is just a reference to a type definition, then I could kind of believe that it's just type followed by an index. But sorry, that was an unnecessary preamble to me just looking it up. So it's in modules, functions, probably type use. Yes, type followed by type ID. Or type followed by type ID, then multiple params, then multiple results. But we've already got that. We've already got the multiple params and the multiple results. I can see it's a bit lopsided and, not quite right here, but it's already there. So I think I was sort of doing this in sort of the order that I expected these things to appear. So I think when export appears, yeah, I mean, as usual, it's a little difficult because this is going to be some kind of abbreviation. Yeah, func ID export name. That is actually just an abbreviation for this export command that we haven't looked at yet. Or export definition, I guess, is the right name. But yeah, first we get exports, and then we get the ID, which should be represented up here. Yeah, well, name it's called. And then we've got this type use business. And then actually, there's a method I should extract in here called something like parse type use. That parses not just this thing that I'm about to make it parse, but also the params and the results, because they are actually part of the type use. But for now, I'll just wang it in here, and I just wanted to figure out what was the right place to wang it, and I think it's here before the params and results, and then so by definition before the locals, because of how total ordering works. So type so this is just going to have to read, I think this is just our standard business that's either a number or an identifier. I must have a regular expression for that somewhere. It should probably be in a constant. Let's just see if I can fish for one. Yeah, here we go. Something like this. This is the kind of thing I'm talking about with refactoring this, is that like maybe refactoring is too high-minded a term. What I need to do is go through this file and just look for repeated patterns, and I can see that there are absolutely loads. Like almost every one of these methods is doing one of like 3 different things. Like here's a common pattern: initialize an empty array and then repeatedly evaluate a block, accumulating the result of that block. Like there should just be a helper method that does that, rather than me manually writing that loop and shoveling stuff into an array over and over again. So I think the refactoring is going to be quite therapeutic because it doesn't need to be high-minded or anything. I just need to make it work. So this says in type, read in the name of the type. I mean, index is fine by me. But also I'm sort of solving the wrong half of the problem, because let me just comment that out, because the error is being caused by unfolding. So let's look at unfolding first. Oh, no, maybe it isn't. I'm sorry. Yeah, I thought it was when I saw this, but I was wrong, I think. I think what happened... Yeah, I think it's because when we're parsing a function, if we find stuff that we don't recognize, then we fall through to just shoveling everything onto this. I should rename this because this is misleading. This is just an S expression. And then we try and parse that as the body of the function. So I think the fact that that type... Oh, yeah. Okay. Yes. All right. I now fully understand what was going on. It shouldn't be getting unfolded because it's not an instruction. It's part of the header of the function, if you like. So it doesn't make sense to implement this in unfolding, but it was getting unfolded because the behavior of this parse function, and the way that WebAssembly works, is that there's no straightforward, as you can see, syntactically, there's no special delimiter that says we finish the header of the function and we're starting to give you instructions. Like, well, I mean, that's not a very good example because those things are all unreachable. But, you can see you just get this sort of parade of result 64, local F32, blah, blah, blah. And then suddenly we're into it and the function implementation has begun. Like, there's no curly braces, or these don't even have to be in parens. They're just... the start of the function is when you stop seeing all of the things that you recognize as being part of the sort of function definition or header or signature or whatever you want to call it. So actually, I think this probably is enough that if I just do this, that's going to allow it to be consumed as part of this process here, and then it won't be rolled into the body. And actually, this is... I can see... No, that's irrelevant. Never mind. I was going to make an annoying point. What? Oh. Yeah, sorry. We have to read type because we're peeking here. Quite rightly. Just trying to remember when I did that, but I think maybe it was just when I wrote it, I decided that we have to read the opcode at this point. Okay, so run that test again. Sorry, I don't know what I'm doing. Unhandled exception. Okay, who's freaking out? We've got a stack discipline problem again. Oh. Right. Right. Okay, so that makes sense because what's going on here is that this is a level of indirection that's referring to this function type. And we've already implemented, to get the stack use right, we've already implemented the functionality that when you call a function, we pop the right number of values off the stack in order to feed it its arguments. So here, this is saying that this function takes a single parameter x, which has to be popped off the stack, and it doesn't return anything. And that's fine, except we I haven't joined these two things up. So when we're interpreting an invocation of this function, we don't look up this ID here in this table of function types, and so we don't know that it takes this parameter. Do I want to look at this now? Maybe I will. It's just, this is going to require a little bit of thought, because at the moment, well, is it? Maybe I can just do this in the parser, because, well, we're sort of getting into, no, we're sort of getting into identifier context territory there. But essentially, I think the module needs to, yeah, for now, I'll do it in the same way as I have the previous, all of the other things that require a bit of sort of module state, which is, you know, like the function definitions get stored in the module and we keep track of what their names are. And I think we just need to do a similar thing here. I am a little bit skeptical about whether this business actually turns into abstract syntax at all, because it could well not. Because you could just say that this indirection here doesn't get represented in the abstract syntax, but I sort of suspect that it does, because otherwise you'll sort of have a blow up in the size of your AST, you know, a linear increase in the size of your S expression could lead to like a quadratic increase in the size of your AST or whatever if you were expanding, especially if there's any sort of recursive expansion of these type IDs. But let's just see. I'm just slightly curious to see what happens to that. So modules, types. Type definitions can bind a symbolic type identifier. Well, that doesn't really say anything, does it? A type uses a reference to a type definition. It may optionally be augmented by explicit inline parameter and result declarations. Right, so that's what we've implemented so far, is the inline ones, but actually this is the more, oh look, we're back here again. This is the more generic form. Function type index, look up X in the type definitions. Not completely clear to me how this gets populated. Okay, this doesn't really matter. That doesn't really matter. I was just curious, but I'm not going to get stuck on that. Okay, so we've just got to hack this out. So I think what hacking this out entails is, right, okay, well, I'm looking at this now, so let's add it to pending. So what is this? Add func.wast to pending tests. I'm going to try to make this pass, at least for a while, so it's helpful to mark it as pending. Okay, yeah, let's be optimistic and sort of fail forwards on this. Adding it to that file is sort of a commitment that it's a weak commitment to the idea that I'm going to try to just get this done. Right, pending failed successfully. Great. Okay, so what I need to do is, at the moment I'm just ignoring these completely. Let me make an action plan. Let's do it under here. type definition action plan. So this is going to be something like actually parse type definitions instead of skipping them. Store type definitions in the module along with their names, just like function definitions. And then when deciding the input type of a function, refer to the, what's it call it? Type uses, refer to the type definition, use the type definition referred to by the type use, if there is one. And then when deciding the return type of a function, e.g., when unwinding the stack after return, use the type definition referred to by the type use, if there is one. And I mean, it sounds like what we need to do is actually sort of combine, it may optionally be augmented by explicit inline parameter and result declaration. So I think, again, this is a sort of, just reading the text and getting confused there, but I think this is just sort of, this is another opportunity to just do what it says that we are supposed to do. So what does it mean for it to be augmented? Oh. Okay, I understand. All right, it doesn't quite mean what I thought it meant. I'm not sure what I thought it meant, but, well, I thought what it meant, and this doesn't make sense, is that, this reference to a type definition, okay, so this doesn't actually have to be a function type, but a function type is like, how many, 0 or more parameters, 0 or more results. And those are, param and result. And what I thought it meant was that you could augment this by just adding more. You could say, well, here are some more parameters, here are some more results, but I don't think it does mean that. This makes me think that you've got T1 and T2 here that are both vectors of 0 or more argument types and result types, essentially. And then this is saying when you look up this index in the type definitions, then the type of the function should be, so let's say that the parameters are like 2 unsigned 32-bit ints and the result is a 64-bit float. Then this is saying when you look up this type definition, it should match the augmentation here. So if you've explicitly listed, in addition to referencing the type definition, you've also said inline, here's a param, here's a result. I think it's so that, this allows binding symbolic identifiers to name the local indices of parameters. So that's the only reason you have these things here. Okay. So actually these don't change and can't change the signature of the function. Can that be right? Because I have been... How does it work? Because I mean that, they're right here. Oh, is this an abbreviation? Yes. A type use may also be replaced entirely by inline parameter and result declarations. In that case, a type index is automatically inserted, where X is the smallest existing type index whose definition in the current module is the function type blah. If no such index exists, then a new type definition of the form blah is inserted at the end of the module. Okay, right, so this is starting to put a little bit of a finer point on what I've so far just been muddling through, which is like, where do function types come from? And the answer is that so far we've only seen this kind so far. I was going to say type. We've only seen this kind of type use. So actually all I'm familiar with at the moment is these inline function types, but that's actually an abbreviation for something more sophisticated, which is, if you just say this, then that's actually an abbreviation for a reference to a type definition with some index X. And X is done by looking through all of the type definitions that we've seen so far and picking the first one that matches the type here. So if this says that it's a function from two 32-bit unsigned ints onto a 64-bit float, X is going to be the index of the first type definition of that kind, literally. And if there isn't one, then we have to synthesize one. So that's quite subtle, and I don't think I'm going to implement all of it right now. But it does seem like something that matters, because this materially affects, well, aside from anything else, it means that there's a new type definition that you could in principle refer to. So because you can refer to type definitions by their index, let's say there are already 10 type definitions in the current module. Now, some of your function definitions could be referring to type definition 10. And that index would be pointing at the last type definition. But then if you have a function that's got an inline type definition like this, an inline type use, I should say, that doesn't match any of those 10, then it's going to synthesize an 11th one and stick it notionally at the end of the module. Oh, no, it's inserted at the end of the module. Sorry, my narrative was going to be, and then the next function you define could refer to the type definition at index 11, because now there is one. But actually, I think this has been intentionally designed so that you can't do that. So actually, because these are inserted at the end of the module, it's like they don't exist at all, because no function definition inside the module can refer to them, because I think these can all be interleaved, and I think you can't refer to a type definition that comes after you. I think you can. This is designed to be that identifier context business. I don't think you have to do it in two passes. You don't have to do one pass through where you collect all the identifiers and then a second pass through where you dereference all of them. I think it's intended to be done in a single pass from front to back in the file. So I don't think it's possible for a function to say, oh, I'm referring to type definition 10, which actually comes after where this function is defined in the file. Like, I don't think that works. So maybe I don't need to worry about this. This is sort of a technicality of the specification that maybe I can just pretend it doesn't exist. I mean, if inherently what I'm doing is just keeping track of what are the parameter and result types of every function, it doesn't really matter how this machinery is explained. I can just implement it however I like. Okay, so sorry, I know this isn't super gripping, but you know what else is new? Okay, well, I'll just work through my action plan instead of just yammering away. Why don't I just shut up and type? No pun intended. So it's inside parse module. It's in here. So really we should have another thing here that says types parse type, isn't it? So where's parse global? Because it should go after that. Maybe I'll do it inline and then I'll extract it because otherwise I'm gonna get distracted. Okay, so what's this got to do? What does parse function do? See, look, I'm already replicating the mess that exists here, and this is why I need to refactor this. But okay, so first what's the syntax? Type ID question mark. So this is indeed correct. This is optional. And then we read function type. No, I was going to say there's no abbreviation, but look, there is. Oh, but it's only abbreviation for multiple anonymous parameters or results. So this, I think, you know, we have to read this. So it says until finished, read expression. Yeah, I haven't actually retained very much of how this works, have I? Okay, fine. I overestimated how much of this had entered my brain. So let's just do parse type here. And then I'll define it down here where this is not ultimately where it's going to go, but this is just my sort of comfort blanket of being next to parse function, which I've somehow decided it's vaguely like. And of course this code up here won't work yet because I don't have this types thing, so maybe I should just add that in before I forget. Is this the right place for it to go? I mean, that's where it was before, so I'm just going to assume that that's right. And then here, this is going to have to take types. And then here, this is going to have to take types. Okay, so that's all plumbed in. Now I just need to actually implement parse type. I mean, maybe that's a good point to... Is there a commit there? Yeah, not that last bit. Because that's the reference to it, which I'm not ready to implement yet. Or, well, hold on. That's not true. I think I am going to commit this. Okay, hold on. There is something that I could do here, isn't there? Like, at the moment, it's just ignoring this. I think maybe this should be something like type index. And then I should actually do something with it. So name, exported name, and then parameters. I think there should be like type index or something here. What did I... index, type use. That's the offset. Index, table index. Oh yeah, it's in call it. Yeah. So here we actually already have this. Type index. Yeah, so I'll call it that. And that just means in the AST we have to add name, exported name, type index. Yeah, because that's what call indirect does, so I'll at least be consistent with that. So I think that is actually a change. So what do I want to actually add? Just that. Not that yet. Not that yet. But that. So now we've got the parser will read it in. Yeah. So unfolding, yeah, as I said, unfolding's not a problem. We add it into the AST. Oh, I haven't done it right. I have to initialize that local variable up here after exported name. Type index. That should also be nil. This is getting a bit long, isn't it? I've got to stop suspending Vim. That's a bad habit. Yes, just that, please. Oh yeah, I staged the rest of it. Stashed the rest of it. Okay, so now, yes. So that fixes the parsing problem, right? So I think I can commit that and say parse type I'm not sure what to call it. I don't know why. Oh, I do have history. It just wasn't working. Yeah, parse type use in function definitions. We don't have a table of types to refer to yet, so this doesn't actually do anything, but at least it allows us to parse the function definition successfully. Okay, and then this is where we start actually doing the work. But again, I think that there's some work here, which is adding types to the AST, adding types local variable here, calling parse type, and adding the result into the module definition. And then this, I'll just take that out and say it's not implemented yet. Store empty type definition table on module AST node. Next, I'll need to implement the parser, which populates it, which populates the table. Okay. Okay, so now let's do that. So I don't really want this to be the same as this, do I? Because I've already seen in here there are numeric type references. So I need to copy. I don't know how and why I lost that regular expression, but that is what I need to do. Okay. So yeah, optional type index. Oh, hold on. I'm wrong. I'm wrong. Because this is the definition. So it is just a, I'm sorry. It is just an identifier. It can't be a number. So I think name is actually as good a name as any there. Okay, so we've optionally read the name. And then we need to read one of these function types. Maybe I could be calling parse func type here. So this is going to be, it's like whatever the rest of this is. So is it going to be one of these unless finished situations? Until finished? Again, I wish I had some more structured helpers that I could call here. I think it's more like this. I think it's going to be like basically with input read do. I think this is right. We're going to read the next thing and then we're going to descend into it and start parsing it as an S expression. So here I should be reading func, for example. So let's just check that. Yeah. So that hasn't blown up in the parser, so this is fine. If I'd said read fun here, the parser would blow up and say, I didn't find fun, I found func. So I've got the right end of the stick. So with input, read. So every time we say with input here, I hadn't really thought about this before because I was just lashing this together organically. But this is really like read list or something. Like this is, well, the combination of that whole thing is like read list. Like we read something from the input which we know is going to be a list, and then we set that to the current S expression, and that means that we can start reading stuff out of it. So I think maybe that's something for rename with input to read list. And it may be that, let's look at with input. How often do we call that with the result of read? Here we do. It's obscured by the fact that it goes into expression, but here we are just diving into the next thing in the input. This is a bit different because we have to formulate this body by... Well, actually, maybe we could... Maybe that's not necessary. This could be the same, actually. If we knew when to stop reading the function header, we could just... Oh no, this is slightly different. It's slightly different. Never mind. But yeah, this one is just using read. This one is literally using read. That one's using read. Okay, so rename with input to read list and make read the default argument. So I think that's something that I should do, actually. But I've put it up there in my refactoring to-do list. Sorry, I'm intentionally avoiding the problem. All right, so we read this func keyword. So what's the difference when it says vec of param? Vectors are written as plain sequences, but with a restriction on the length of those sequences. Well, that doesn't really sound like something I care about, at least not at this stage. Plain sequences. So that's just saying A repeated as many times as you like. Well, up to 2 to the power of 32 times. So I think this is just saying param, 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 param. And param is brackets, 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 brackets. So oh, right. The optional identifier names for parameters in a function type cannot be referenced from anywhere. So you can put names in here, but they don't do anything. So I think that's good for me to know because I can just ignore them. I just have to skip over them in the parser and not store them anywhere because they're not going to be relevant during execution. Or even validation if I ever get around to implementing that. So, all right. Okay, so we're going to have to... Yes, so this is going to have to be until finished. And this is just going to repeatedly read. Well, it's going to say, again, with input read do. So we've definitely got a list. It's either a list that starts param or a list that starts result. So I can say case peak in param in result. I think that's right. In fact, I guess this can be case read, can't it? Because I don't need to know. I don't need to. It's fine. I can throw it away. All I'm going to do is it's just going to change the control flow here. So here, if it's param, there's an optional ID. So I'll read it, but I won't save it anyway, because no one cares. And then val type, which is a type, none type, vec type, ref type, I32, I64. So what have I called that elsewhere? I mean, the temptation is just to call it type. I haven't even bothered to make a regular expression for what that can potentially be. But it's like whatever it is, it's just the type. I think I'll just call it type for now. Maybe it should be val type. I'll leave it like that. Well, hold on. I must have encountered this elsewhere. I think it's this. And here with results. Yeah, I remember this is all a bit wonky, isn't it? Here I just completely ignore the type. Well, yeah, at this stage we really don't care what it is. We just care how many there are. But here, I mean, maybe I can use the same technique here. Maybe I can just use these parameters. Yeah. Yeah, maybe I can do that. Oh, and look, this does have the abbreviation that's alluded to here. So it's like if there's an identifier, so the identifier is optional, but if you've got one, then you're necessarily declaring a single parameter. And if there isn't one, then you can actually have as many as you like. I think I'm just going to copy this because this is basically doing the right thing. So up here, I want to have like, well, somewhere. I'll put it right on the outside. I think, and I'm going to have results as well. So there is actually, again, there's some duplication here, right? That the syntax here is the same as it is for the inline ones. And I've already got the code to deal with the inline ones when we're parsing a function. So it makes total sense, and I'm just going to copy this as well. That was it, reading result, I think. Why does it do that? Oh, because we might need to fall through to this. Right, okay, well that's a refactoring problem. Right, so we read the name of the type, and then we go through and we read the parameters and the results. Yeah, you can't have, so this one just drops into this same loop, right? Because you can't, there is no support for having an identifier there. So this is just going to fall into a loop that allows you to have as many results as you like. And at the moment, yeah, this is really wonky. Because we don't have an object that represents results, we're just sticking the type straight into this array, because all we care about is the arity of the function. We care about how many parameters it's got and how many results it's got. And yeah, like I said, these names are actually irrelevant, but like, I think for the sake of reusing this code, which I realize I'm not, I've just copied and pasted it, but like when I extract it into a method that does this, we might as well just let it store the name, even though it doesn't have any effect, because then I can just reuse that code. So I think that's the parsing bit. What happens? Okay, nothing bad is the answer. So I haven't actually done anything yet. This doesn't return anything useful. But it probably should. Now this is called functype. Do I want to call it that? Yeah, I suppose, because I need a container to hold the parameters, the name, the parameters. Oh, It's more like this, isn't it? Like when we create a function, it binds together, in the AST, it binds together the name and the parameters and the results. So I do need an equivalent here for the interpreter to use. Would it be bad to just call it type? Like that's what this says. Type definitions. So in the same way that function definitions are currently called function, I think I'll call a type definition type. And this one just has a name and then parameters and then results. And then I'll just need to actually stick that in the AST, right? Okay. So now let's see that work. Yes. Okay. So let's say I'm not quite sure how to factor that out, but I'm not gonna worry about that for now. I'll do that later. If I can get this, I've already got NOP. If I can get func parsing as well, then I'll sort of feel like that's enough motivation to get stuck into cleaning up this parser a little bit. So that's my current plan. Let's see how that goes. So how am I getting on in my... How am I getting on in this? Actually parse type definitions instead of skipping them. Store type definitions in the module along with their names, just like function definitions. Yes, I've just done that, although I haven't committed it. So have I really done it? No. So let's say... create type definitions during parsing. I don't really know what to say about that. Well, what I can say is a lot of this code is duplicated from parse function. So at some point we should refactor by extracting some helper methods. For now, I'm trying to get the test parsing. Okay. So that's good. So now what? Right. Now, when deciding the input type of a function, use the type definition referred to by the type use, if there is one. So how do I know if there is one? Oh, it's if there's a type index on the function. So now we're in the world, for now, we're in the world of the interpreter to make this decision. So when deciding the input type of a function, so that means we'd be looking at the parameters of the function. Yes. Oh, this is a little bit tricky because in fact, maybe, no, okay, what I'm going to do is, it's going to make it harder to share the code later. I was going to say we should ignore the parameter names here, but no. I think what I'll do is make it so that the parser leaves them there, and then it's when we do this invocation we have to be careful to not let the names in the type definition. Oh, this is all going to go away, isn't it? I know this is the billionth time I've said this, but when we've got an identifier context, all of these names are going to go away anyway. So this is only a short-term problem, he says. So it's not very important. The operational semantics aren't going to say anything about this because there are none. All of these names go away at runtime. They just become indexes. So, okay. All right. So this is one place where I need to do something. Oh, this is actually the only place. Okay, well that makes sense. It's the only, and in fact, this is the problem that I'm trying to solve right now. Is that I think it's not the result type of the function that's wrong. It's the argument. It's like the input type is not right. So this actually needs to be a conditional that says if function type index nil, then we should do this. Well, it's this. Else use the type definition, but make sure we ignore names. So this is going to be, so we don't actually have the current module, do we? So hold on, what happens when we get the module? We've got a table of types here. It's just an array of types. Table's a very fancy name for it. And I think I should have self.types equals types. And we should have types here. So, okay, yeah, I mean, it's becoming increasingly clear that we should just hold on to this. We should just hold on to this module instance because it's got all the stuff that we need. Although, yeah, the memory and the global is slightly less so. But anyway, just continuing as we are. Remember all the types. And then in the same way as we just end up having to do this, we just end up having to detect the function. I think we're going to have to do the same thing here. I'm sort of surprised that there's none of these are trying to distinguish whether it's a, sorry, I'm getting distracted again, but none of these are trying to tell whether it's a numeric index or an ID. It's just assuming that it's an ID. But in this case, we're actually going to have to support both of those. Hold on, that's just made a thought happen in my brain. So this type use is either a label or it's a numeric index. But if it's a numeric index, then we need to turn that into an integer. So I've sort of forgotten to do something here. Sorry, let me stash that for a second and then just, because that means I've got unfinished work in the parser. So where do I do this? Yeah, here we go. That thing again. Yeah. So there's plenty of places where we do this, but I hadn't copied and pasted it to the place where I need it to happen this time. So again, just quite bad hackery here, but it will all, you know, I'm hewing to a particular kind of plan here, which is to just make a big mess and then sweep it all together into nice little neat piles. And I mean, I accept that that's not the only or even necessarily the best or even necessarily a good way of doing this sort of thing. But it's how I've chosen to do it. I mean, it does help to avoid getting sort of design paralysis up front, because approaching things in this way, you tend to, you know, you sort of start chipping away at the block of marble, and to begin with, it's very rough and sort of not right. But then the more you chip away at it, the more pieces start to emerge, and it's not a good metaphor, but as the dust settles down into the cracks of the problem, you actually start to see like, oh, there is some structure here. And if I'd thought about it properly, I would have realized there was some structure here, but I didn't think about it properly. I just mucked around trying to get the test to pass, and now the structure has been revealed, and now I can codify that in terms of classes or methods or data structures or whatever it is. So I'm just sort of, basically it's just being a cowboy. So that's what I'm doing at the moment. So yes, I'd forgotten to do this. I think it was this. Commit. Yes. So let's just stick that in. Good. So that's now there as it should be. Right, so we are going to get an integer out. That's what we want. So now use type definition if there is one. So I'm going to have to do like type equals. How have I done this here? Do I? Yes, here. Oh, yes. Well, that's where I've got things in a sort of association list, isn't it? Which is rather different than my current situation. So if the type index is a string versus an integer, so a string, we're going to have to look it up. So that's going to be types detect type name equals what am I talking about? Which way around do I normally do this in a detect? Underscore one dot name equals name. Okay. So we're going to find the type whose name agrees with that. I guess we'll raise if that doesn't work. Otherwise, we're just doing type slice, type index. And I think that will raise if it's out of range. No. Okay, so I need to raise on that as well. Well, let's just make this whole thing raise. Okay, something like that. Use type definition if there is one. Okay, so having found the type definition, I think what I want to do is say parameter names equals types.parameters.map nil. So it's as if they didn't have any names. So actually what we're doing is we're retrieving them. Type parameters, nil. And then we're just making a nil for each of their names. So we're not even looking at, although they've been parsed in here and stored in the parameter for the sake of sort of consistency with function. In this case, we're not going to use them to identify, we're not going to have locals with those names. Again, not actually a runtime concern, but currently is, because I haven't done it properly yet. So if I haven't mucked anything up, I'm expecting this test to, if not completely pass, then for us to have a different error than, oh, no, stop. That was not at all what I wanted. Let's remind ourselves. So this is what we had before, and this unhandled exception was because the stack was non-empty, and I think that's because we hadn't popped the parameter off the stack. So let's see if this has at least changed that. No. It hasn't made any difference. Okay, well that's unfortunate. So here, let's say puts using inline type, and this is using type definition. Okay. Type is type inspect. Okay, well that's all correct. Oh, this is the problem. I didn't even use it. I did all of this work to compute the parameter names, and I'm not even flipping using them. I mean, they're used here, but... maybe I should set both of them. Parameters here is function.parameters. Parameters here is type.parameters. And then, yeah, we can, that's okay, because we can use it here. Right, and they do need to be in the conditional, because actually whether we use the names or not at this stage is material. So this just needs to be parameters.length. So surely this is now going to, let me just optimistically, but not too optimistically, because then I would delete them, comment out my debugging code here. Hey, it's passing. Okay, great. Nice. All right. Very satisfying. All right. That's cool. What were the steps that I took to achieve that? Actually, not very much. So this first thing here was store the current modules types. Hold on, I just had another thought, but let me finish this. Store the current modules types in the interpreter state. Type definitions. Typing that in just made me think about how what I said earlier about the order being important. I mean, I don't know if it's important, but my expectation is that if you have... Okay, just ignoring names for now, because Names are problematic because I haven't got the identifier context, but just thinking purely about indexes of types. If I've got a type definition 1, say, I don't know if they're 1 based. In fact, I do know they're not, they're 0 based. So let's say, because it worked when I looked it up in the, I'm not adjusting the Ruby's 0 based, and I'm not adjusting those indexes to make them 1 based like it was Lua or something. So assume I have type definition 0, then I have a function definition that is referencing type 0, and then I've got type definition 1, and then a function definition that's referencing type 1. Then if I have another function definition that's referencing type 2, but then the definition of type 2 comes physically after that function definition in the file, is that valid? Because right now that information gets lost because instead of piling up the way that I could represent modules is I could say like, it's just a collection of definitions. It's just an array of definitions. And then the interpreter has to chew through them one at a time and do whatever it needs to do to make sense of them. Then the order would be important. But now, because they're segregated out into all of these separate lists, you've got no idea which of these types were declared before or after which of the functions. They've been, untangled. I don't know if that's problematic. I guess it's probably a validation concern. If it matters, it feels like it would matter during validation. Let me just briefly take a look. This doesn't make any difference to what I'm doing right now. Functions. So what's this saying? Oh, never mind. It doesn't matter, does it? At some point, I mean, I would hope that the tests are going to bring this into focus, right? Like, I don't actually need to understand it, because if it matters, there'll be a test for it. And if it doesn't matter, then there won't be a test for it. And so it's up to me what I decide to do. So anyway, store the current module's type definitions in the interpreter state. We'll need to refer to these during the invocation of functions functions containing a type use and containing a reference to a type definition, so that we know how many parameters it has. Actually, typing that has made me realize that this code is not quite correct, because you can have both. You can have a type, you can have a reference to a type definition here, and also you can have inline parameters if you want to give them names. And at the moment, again, for now, the name resolution is being done in the interpreter, not in the parser. So actually, this conditional should be the other way around, or rather what it should be doing is checking for this case, because the reason I need it at all okay, when does it matter? It only matters when there's a type definition. So this is the right condition. If there is a type definition, yeah, it's this line that needs to change. So if we've got a reference to a type definition, then when we've picked it up, we've got a decision to make about, well, which parameters do we use? If there weren't any inline ones, then we have to use the ones from the type definition, because that's all that we've got to refer to, even though we should be discarding the names. Oh yeah, no, it's both. It's both. Okay, so this is like if there are no function parameters. Okay. All right. So let's say if function parameters is empty, then what we were doing was correct. But otherwise, we should do this. Because in that case, the whole reason that these inline parameters are there are so that we get the correct names. I think this is at the point where there's really no point in having the parameters here. In fact, this local variable gets clobbered. So I think it would actually be better, because we only care about the name, the length of this. So we might as well make this be the length of the parameter names array, get rid of all of these parameters variables, and then we inline this here, function.parameters.map. This becomes type.parameters.map, and this becomes function.parameters.map. So that's a little bit more honest. I was going to extract that into its own method. I think I should. Because ultimately now the only job of this chunk of code is to get the parameter names, because that's all we need. And it's either going to be an array full of nils, or it's going to be an array full of strings, or a mixture, because these, well, these could well be anonymous actually. So that this is going to be nils and strings, whereas this one is definitely going to be nils. Let's just run the test again. Yeah, so that's fine. So that wasn't important for the purposes of this test, but in fact, this whole thing, we can just lift that assignment out of this, because that's what the return value of this whole conditional is just the parameter names. So that's cool, I suppose. It's cool that the test's passing. Yeah, I'm just trying to think whether I can split this up anymore, but I don't think so. Dereference type index during function invocation if present. Well, during function invocation, dereference type index if present. While we're still handling names in the interpreter, i.e. until I finally implement the identifier context in the AST parser, we need to be careful that the names from the type definition don't leak through into the local variable names, because the spec says they shouldn't. Says there purely for documentation purposes. And let's find a reference to where I read that. It would be under type definition. What? Oh, function types. Okay. Cool. And I'm also going to need to change my test script. And move this to this. Let's just let that run through. All right, great. Okay, I think I will extract that method while I'm in there because this is very easy to do. So what's this? I think it's just this. Yes. Looking good. Let's call it a helper. Okay, that's a little bit less painful, isn't it? All right. Well, I mean, that was 2 hours. So I haven't done this when deciding the return type of a function. So can I find, is now the time to do that? And can I find a failing test that makes me want to do it? Are we already, what's the situation with return.wast? Yeah, that's all already passing. So yeah, I'm not sure what my motivation is to do that. Let's just look at some of these other tests before I move on. Have any of these changed their situation? This one, no. Haven't done anything to... Oh, so func.wast is done now. What was the problem with exports.wast? Saying, and this is the S expression parser has failed, so I assume that there's nested, yeah. Needs nested comments in S expression parser. Why don't I briefly look at nested comments before I move on? I think I'm gonna I'm just going to leave this. I'm not going to do this now because I don't have any way of knowing if it's working right because I don't have a test that's failing because of it. However, I do have some test failures that are to do with, well, these, you know, this isn't even a test failure. This is like, you know, the test can't even run because the S expression isn't even being parsed correctly. So let's take a look at that. Exports, I'm not sort of expecting that to work, but global, it would be nice if it worked. Well, let's just have a quick look at that. Like, do I have any expectation that this will work? I mean, it's just global set and it's got imports. All right. I don't know what this does. Everything else in here looks like stuff I've implemented, to be honest. I just don't know what this global import thing does. But let's see if we can get it over the hurdle of the S expression parser not working. So amazingly, unusually, I actually have some unit tests for the S expression parser. So something like this, I want to be able to say hello world. So it's like an inline comment. Oh, that was inside a string, which is absolutely not what I want. But it does actually look like that's the only test I've got for... that's a bit bad, isn't it? I don't appear to have any test that actually... Oh no, look. Here. That test, look. Okay, yeah, sorry, yeah, look. I've got all sorts of... What am I talking about? I've got all sorts of tests. Hello, cruel world. That needs to just be... yes, okay, so this is the S expression. So it needs to be something like that. So at the moment, I'm expecting that unit test to fail. Wow, it's been so long since I ran that on its own that it's not in my history. S expression parser test. Right. No good. And we also need, while I remember, to support nested ones of these. So yeah, we've got to be able to support. I think this is the right, yeah. It's like winky faces. Right. I don't support that at the moment. Better add support for it to the S expression parser. So it seems that the place to do this is in skip whitespace and comments, because I'm already doing the thing that skips literally spaces and new lines, and it skips semicolons up till the end of the line. So we just need another regular expression here. I'm going to go out on a limb here and assume it's going to be non-trivial, or at least it's going to be longer than these ones. So let's put it in a constant. Does it have a name for these? I would call them block comments. A line comment or a block comment. Okay, so let's say block comment regexp equals. So what's this going to look like? Well, else if can read block comment regexp, then read block comment regexp. So that's easy. What does this look like? It looks like an opening parenthesis with a semicolon, and then a closing parenthesis with a semicolon before it. Well, essentially it's any number of any character but it can't be. It's not any character. It's not allowed to be. I'm just trying to think of the easiest way of expressing this in a regular expression. It's what I should have just finished saying is it's not allowed to be in, for now, it's not allowed to be an opening parenthesis that's followed by a semicolon, and it's not allowed to be a semicolon that's followed by a closing parenthesis. What's the nicest way to represent that? Well, so let's say, well, straightforwardly, we could say this could be any number of characters that is not a semicolon or an opening parenthesis. Because an opening parenthesis could be the beginning of a new comment, and a semicolon could be the end of this comment. So there's that, and I think that's going to make the first of those tests pass. So this, however many dots that is, it goes up to the I of Wasmina. O. So what's changed? We had a parse error, and now, I mean, have I just... Oh, I think I wrote the unit test wrong. Because I think, yes, it's supposed to be in double. So actually that should have passed. It's just that I wrote the assertion wrong. Sorry. It's been so long since I did this. I forgot that the input here is actually a list of S expressions. So it actually needs to be double square brackets for that to work properly. Okay, right. So we're now up to the N. So that made the first one pass. The second one, right, it was unable to find a closing winky face where everything in the sandwich was allowed because it hit this opening bracket. So obviously you should be allowed. So that's another test we should have here. You should be allowed to do this. There's no nesting there. You know, I think that should all be okay. And at the moment, I don't think it is. Yeah. So that's all wrong. What's the nicest way to express this? This is a slightly clunky way of expressing it. but this is the most direct way of doing it, is to say it can be an opening parenthesis. Well, look, I don't know why I'm bunching this up so much. I can split it out, can't I? So it could be an opening parenthesis or it could be a semicolon, but it can only be an opening parenthesis as long as it's not then followed by a semicolon. And it can be a semicolon as long as it's not then followed by a closing parenthesis. So that's one way of doing it, is by using these negative look-ahead assertions. I think that would get me another test passing. Yes. So that deals with the case where there aren't any nested comments. And then to make nested comments work, we just need to have another option that is not just, that is, you know, that allows us to go up to not just this closing winky face, but yeah, to have an alternative to this. So it's like some amount of this, or a recursive call to comment, which I will put in a second. And then this whole thing. So either you can have a string of stuff that's inside a comment, or you can have a nested comment, and that whole thing can be 0 or more times. And then we just need to give this whole thing the name comment, so that this \g, sorry, let me give you a citation for that. So this is sub expression call is what I should have said. So this lets you, it's actually very similar to this example. So if you've got a named capture group that you've already defined, which in this case I have, good point, I should be anchoring this. Yes, I need to anchor it. Maybe this does the anchoring automatically. How does read work? Try match. Yeah, it does the anchoring automatically, look. Yeah, so if you've got a named capture group called, in this case, paren, then at any point, if you use \g to refer to it, you're saying you can match that again. So it's allowing us to sort of, this is a real Tony the Pony situation, that like, this actually does allow us to, this allows us to match non-regular languages. So this is not really part of the sort of formal class of things that a finite state machine can do, a deterministic finite automaton, which is normally what you'd think of as a regular expression. This is more of like what you can do with a pushdown automaton. This allows us to sort of, because you need something that's like a stack here, you need to be able to say like, well, we're sort of descending a level, we're matching this thing again, and then when we're done, we're going to sort of pop out a stack frame effectively and then carry on matching. I mean, that's a lot of waffling. I haven't run the tests yet. Yeah, okay. So that works. Okay. It's not the easiest thing to understand, is it? And sometimes that's sort of inevitable. Yeah, you're right, Marco. It is pretty nasty. What happens? I mean, I assume that I assume I need this. I mean, what would happen if this... I mean, just humour myself here. If that was just any character and then I make this non-greedy... No, that doesn't work. Well, I mean, life's hard, isn't it? I think this is one of those things. In fact, I can almost guarantee that this is one of these things that where I'm gonna wake up in a cold sweat at 3 a.m. and be like, wait, what was I thinking? There's a much easier way of doing this. But I can't right now think of what that would be. Because if you allow this to... Oh, hold on. That's interesting. I just said any character. Yeah, I mean, it's not a very lovely syntax for multi-line comments, is it, Marco? Why does that work? I would at least like to think about why that works. So this just says any character 0 or more times. Okay, but I'm worried that that is allowing something that it shouldn't allow. So I think my concern would be that... Yeah, because it's important that syntax errors don't get through this. So I would... I'm not quite sure how this works. Yeah, I'm just trying to think of like what do I think the actual problem is here? Yeah, I'm having trouble getting my head around this. Oh, you're right, Marco. Yes, I think that's right. I think you're right. It's being too eager, isn't it? Yes. So I need to be able to say happy. Yes, right, exactly. Something like that. This needs to be like this. Right. Yeah, so it's being too... That's exactly the problem. Thank you. It was for some reason my brain was just freezing there. I wasn't quite seeing what the problem was, but yes, it's going to be too eager. It's going to eat its way through that closing delimiter quite happily. And I also don't think it's enough to just make this non-greedy, because I think we saw that didn't work before either. So I think really the only way to make this work is to... Yeah. Is to force it to... Yeah, I mean, I think I'm just going to live with this for now. I know it's not ideal, but it's not immediately jumping out to me. Not immediately jumping out to me how to make this any less bad. So I think I'm just going to go with it because this achieves what I wanted. I think I am going to be embarrassed when I realize that there's an easier way of writing this. So Marco, you've said it might work if you do anything but semicolon close bracket. But how do you write that? How do you say anything but semicolon close bracket? You know, we've got to make it stop when it's about to hit a nested comment, right? So even let's assume that we could write anything. I guess what you mean is anything that doesn't contain semicolon close bracket. But then that's going to allow it to eat into the beginning of a nested comment, because that isn't semicolon close bracket, it's open bracket semicolon. So that's why I need something that has this effect that allows me to exclude open brackets and semicolons, except when they're of this special type, like when it's an open parenthesis that doesn't have a semicolon after it, or a semicolon that doesn't have a closing parenthesis after it. I think I'm just gonna, this is not very interesting, so I think I'm just gonna stick with this for now. And say something like add block comment support to regex sExpression parser, and say something like this regular expression is pretty nasty, but I'm having difficulty thinking of a nicer way of doing it off the top of my head. I'm sure there. Oh, hi Joel, thanks for joining us. I'm sure there is one, but when I think of it, I'll just come back and change it. Joel, you're probably better at this sort of thing than me, given your open source project. I'll just drop this into your brain, and then if you think of a better solution, I will gladly integrate it at this stage. So WebAssembly has this sort of unpleasant, and you can't tell, but this is a comment. It has this like block comment syntax where you can have open parenthesis semicolon and then any amount of text and then closing parenthesis with a semicolon inside it, and these can be nested. So what I'm trying to do here is come up with a regular expression. I mean, this is a little bit unnecessary now that I think about it, because this is a recursive descent parser. So actually, I don't have to do it with a regular expression. I could do it with a recursive descent parser as well. So I've only just realized that actually maybe that would be the nicer way of doing it, and maybe I should say that in the commit message. Alternatively, I don't actually have to do all this with a single regular expression. This is a recursive descent parser after all, so I could just implement, parse nested comment, which can call itself recursively rather than rely upon a sub-expression call in the regexp. unfortunately, Marco, the font that YouTube is displaying your comment in is makes it quite hard to see. Makes it quite hard to see what you're suggesting there, but I'll check it later. Okay, I feel like I've spent the right amount of time on this just to get it working. Yeah, Joel's saying I probably wouldn't use a regular expression for this. So, yeah, unfortunately, I'm slightly hypnotized by the fact that I was inside my in my S expression parser. I was in this skip white space and comments, and this code was already all here, which was just skip spaces and new lines and skip semicolons. These are single line comments up to the end of the line, and I just thought I'll just put another regular expression in here, and then it's only when I started to write it that I realized that it's actually not very nice. Anyway, I'm going to relegate that to a future refactoring to come up with a better way of doing that. But thank you, Marco and Joel, for trying to for trying to coerce me out of that obvious error. So, okay, why was I doing that? It was in the hope that, well, at the very least, it would allow us to parse the S expression in this global. Oh, what have I done? Why did I? What? I obviously fat fingered Git there. I'm sorry. Vim even. Well, yes, fine. So yeah, Chris, that's a good question. I think that what you suggested is valid. I think you're allowed to So this is what you were saying, right? Oh, interesting. Right, well, now that I look at what you've said, I think that's not valid. I think if you were to do that, then that's fine. But I think the fact that, yeah, I don't think you should, I mean, let's see what the spec says, but I think it's going to be, so, yeah, look, if I just, my regular expression is basically a transcription of this grammar, isn't it? It says that a block comment is bracket semicolon followed by 0 or more block characters followed by semicolon close parenthesis. And then, yeah, look, this is exactly what it says. I should have just read this because this is more of a justification. So it can be any character that's not semicolon or open parenthesis, which is what that is. Or it can be, well, okay. In fact, why don't I change this so that it matches the grammar they give here. Semicolon if the next character is not closing parenthesis, or open parenthesis if the next character is not semicolon. And then here they're just recursively referring to block comment, which is what my sub-expression call is doing here. I mean, the one thing that this does make me realize is that this asterisk is redundant. So maybe I'll take that out as well. I mean, I think I just do that sort of out of habit because I want this to eat as many characters as possible without having to go to this outer, sort of outer capture group here. But the comment test. Very clever, Chris. Thank you. Is it comment or comments? Comments. Right. Well, this looks like a candidate for something that I should be able to, that should be passing now, right? So hold on, let me just get a grip on myself for a second here. Okay, I think seeing this, I know, trust me, I understand how gross that regular expression is. But it does very closely match what is in the spec here. So I think that's a little bit more justifiable. Okay, this regular expression is pretty nasty, but it corresponds directly to the grammar in the spec. I'm going to stick with the regex for now because it's working fine and I don't really care about the S expression parser anymore. I mean, that's the reality. Like, as long as it works, and I think the fact that that is now a straight transcription of what's in the spec makes me feel a little bit more relaxed about it, even though it's not the most readable part of this program. So yeah, let's see what happens now that Chris has pointed out. No, it's okay, Chris. I was about to move on, but actually, see, like, if it's not, oh look, there's a tab character. See, that's the kind of thing that I should be flushing out. Let's fix that. So here, can read space new line. Let's also add tabs into the mix. I mean, I don't know why I put it on the end. I don't know why I didn't put it on the end. For some reason, it felt like new line should be on the end, but of course it doesn't matter. Hey, comments.wast. You are, well, I mean, it doesn't have any assertions in it, but the challenge here is apparently to successfully parse this without choking on any of the weird white space or null bytes or horrible nested comments. So actually, Chris, I'm glad that you intervened because I either didn't know or had forgotten that existed. So that's actually pretty cool. Right. \s for space and tab. Perhaps. What exactly does \s match? A white space character. So that's tabs, carriage returns, new lines, whatever \f is. Yeah, I know it's white space, but like, what is the, for example, I previously, in my attempt to be clever and use a POSIX bracket expression to match digits, it turned out I was matching all possible Unicode digits, which was not my intention. So I just want to be a little bit careful about what specifically this matches. And what does, because what I don't want is to get myself in a situation where I'm not. So it's not like, I don't think it is things like non-breaking spaces. It's not like the full panoply of Unicode white space. It's just these 5 things. What's \f and \v? I don't know. That's too obscure. Well, \s is non-white space. Capital S, sorry. let's just see what does I'm you know I haven't thought about this before. What does WebAssembly think whitespace is? Whitespace. Any sequence of literal space characters, formatting characters, or comments. The allowed formatting characters correspond to a subset of the ASCII format effectors, namely horizontal tab, line feed, which is what I sort of thought F might be, but it felt too ridiculous to say it, and carriage return. So carriage return is \r. So if V is horizontal tabulation, right, so Joel says \f is form feed. Okay, that's great. Now is \v horizontal tabulation? 11. Oh, vertical. Oh, okay. Vertical tab. Right. Okay, horizontal tabulation is just normal tab, isn't it? Yes. Of course it is. A subset of the ASCII format effectors. So what this suggests to me is that I can't use \s, or at least I officially shouldn't, because it can be a literal space character, done. It can be specifically these formatting characters, or it can be a comment. So what I should do here is put \v in. No, \f. Don't be silly. And let's just double check that's character 10. Oh, it's 12. That's not right. Literals. String literals. Oh, so by line feed. Okay. All right. Line feed is, of course, new line. Carriage return is carriage return. So this is \n, this is \r, and this is tab. So I've gone completely. I've completely lost my mind. I've forgotten what all characters are, what all formatting characters are called. We don't want any of this funny business. We just want CRLF and tab. That's what we should be doing. I'll do them in ASCII order. Tab. New line. Carriage return. Whew. Okay. All right. So let's put that to bed once and for all. So this is support. Let's say treat tabs and carriage returns as white space in S-expression parser. This is how the WebAssembly spec defines white space. Well, it's like this plus comments is how it defines white space. Okay, so now we can add comments to this. And let's just let that run. And yeah, I mean, useful to check that those changes haven't broken anything. but that's looking hopeful so far. Okay, and then the actual problem that I was trying to solve before I got sucked into this nightmare is I think it just doesn't know how to parse this properly, basically. I am going to make a decision based on how complicated that turns out to be about whether I want to do this or not. Global import spec test. I don't know why I'm looking here, because I need to look at the WebAssembly specification for that, because I think, much as I would like this to be a weird artifact of the testing script, I think this is actually a WebAssembly feature. Imports. Well, let's look at globals, because that's my entry point. Global ID, global type. Okay, so that's just a regular... Right, so it's attack of the abbreviations again. So global ID import should become import. Okay, so what is an import? The descriptors and imports can bind a symbolic function, table, memory, or global identifier. So what does this even mean? Import spec test. So what is spec test? So I assume this is part of the what is provided. So this is why I started going to this URL, is because I was thinking this has got to be provided by the test environment that the reference interpreter uses. But how do I find out what that is? Import spec test. What does this mean? Well, let me just update this. So we don't know what exports needs anymore. We know that this needs import spec test, which also is what names.wast needed. So it's only mentioned in a few of these tests, and then we're into the implementation of the interpreter. So it looks like the runner that they use. Right. So this is sort of, I've not really used WebAssembly. I've never written any WebAssembly, and so I don't know very much about this, but this sort of accords with my expectation that the whole idea of WebAssembly is that you define modules, and those modules can both export functions to the host environment in which the WebAssembly is running, and they can also import functions that are provided by the host environment. So this, to me, looks like this is what allows you to provide native functions, like from the WebAssembly program's point of view. These are just like functions in the environment that it can have access to. So, I mean, they don't appear to have explained this anywhere in They don't appear to have explained this anywhere in this reference interpreter, but this does seem to be the assumption upon which these tests are written. Let me just check. I mean, I said that they haven't explained it. It's possible that they have explained it, and I just haven't found the explanation. But, you know, worst case scenario, that JavaScript code is a pretty good explanation of what each of these is supposed to be bound to. So, for example, print i32 looks like it's a function that knows how to print a 32-bit integer, which in JavaScript is console.log. So I could certainly implement that. Spectest.ml. Oh, look. Why didn't it find that when I searched for spectest? Oh, I'm sorry. I apologize, maintainers of this. I did search for spectest in the page and it didn't find anything. So either I messed up or some combination of Chrome and GitHub messed up. So I'm sorry about that. When running scripts, the interpreter predefines a simple host module called spectest that has the following module type. The print functions are assumed to print their respective argument values. So this is sort of... Okay, so this is deprecated because now there's some other command that lets you register in some other way. Register module for imports. Well, okay, whatever. I don't understand how that works, but fine. Okay, so this is saying that the test environment exposes 4 global variables with these names, I think, a table with these contents, a memory of this size, and then all of these functions. Do I want to look at this now is the question, because this was definitely more, I was sort of hoping, well, in fact, I never hoped this, but I was sort of hoping that if I just got the S-expression parser working, then somehow something would magically start parsing. And indeed it did. The comments.wast started parsing. But sadly, it looks like I've got a couple of things that are blocked on this spec test business. Add comments.wast to parsing tests. This just needed support for nested comments and tab character white space, which we now have in the S-expression parser. Okay. I think, given that I've been going for 3 hours, basically, that I'm going to shift gears. And what I said at the beginning was that I wanted to get some momentum back and feel like I'd, made some progress. And I have made some progress. It took me longer to write that git command than I really wanted it to. But you can see I've added nop and func and comment. So it's not quite 7 tests, but it is more than 0 tests. So that has made me feel like I've made a little bit of progress here. I've got a little bit of momentum. So that's good. So I think I am going to switch gears. So I've done pick a test, make it pass. I've done implement nested comments in the S-expression parser. I've now got this sort of implement the spec test module and make it possible to import e.g. globals, which is what I've already forgotten what test we were working on there. Global, yeah, which is what the global.wast test needs. Which is what the global test, yeah, okay. So I think I'm going to switch into yeah, I'm going to switch into having a look at cleaning up the mess I left last time, and it's not a super appealing prospect. But I also don't just want to leave that mess, because I think the more time I put between me making the mess and me cleaning up the mess, the more likely it is that I'm just not going to remember what I wanted to do here, or why, or how it works. So I think I'm going to use that little bit of momentum of having implemented this recently to just go through and do some of that cleaning up I was talking about, and sort of try and factor out those many patterns that currently are just repeated all over the place, and actually make this code a little bit tidier. So the first thing I set up here that's relevant was that I think maybe with input should be like read list, because that appears to be what it is. So yeah, with a little bit of distance from it, I think that's what it's doing. Like, we should only be calling this when we're expecting to then be able to say peek and read and stuff like that, because if you set the S expression to an atom, you can't actually do anything. Like, all of these, it'll call first on it, it'll call shift on it. Like, those aren't legit things to do. So I think that sort of expresses better what it does. I mean, this is making me think a couple of things. Thing the first, should we have some kind of, for my sake, should there be some kind of runtime assertion that the thing that you're trying to read is actually a list? And to that I would say probably yes. And then secondly, I would say, again for my benefit, should there be some kind of assertion that when you've called read list, that whatever you do inside the block, given that when you call these things, it destructively consumes the current S expression, should there also be an assertion at the end of read list that asserts that the list is empty? Because if it isn't, then I've forgotten to do something. And I mean, there are probably plenty of places. I mean, I can see one already. Well, two already. Both of these to-dos. These are places where, because I don't really care, because it's something that I haven't implemented yet, I'm not reading what's there. And that feels like, I think having that sort of confidence that every time I've said that I'm reading a list, that I've actually read the whole list, will, I think, cause the parser to fail faster in situations where I've made a silly mistake. So I think perhaps I am going to do that, but let's do it in pieces. So for this, I'm just saying, rename AST parser with input to read list, with a bit of distance from when I first named this method. It does appear to be used only when we want to read a complete list from the input. For my own safety, I should probably be asserting that A, the thing I'm trying to read is actually a list versus an atom, and B, the list I've tried to read has been read to completion. I'll do that next. So Joel, what I'm talking about is, like, here's a good example. So this is the part of the parser that is trying to parse what are called commands in the test script. And those commands might be to define a module, to invoke a function, to assert that the return value of some function is equal to some value. And then there are these other kinds of assertion that I've seen so far, but that I haven't implemented. And so because I haven't implemented them, Whereas in all these three cases, if I call parse module, parse invoke, or parse assert return, they will consume the remainder of that S expression, right? So in the case of module, the remainder of that S expression is all of the function definitions and stuff inside the module. In the case of invoke, that's the name of the function to invoke and the arguments to call it with. Now, all of these things have got arguments as well, and actually, depending on what the kind of assertion is, it might have a different number of arguments. But because I haven't implemented them yet, I haven't tried to read anything from the input. After I encounter one of these, I just sort of bail out and say like, well, I can't be bothered to read anything else. I'm just going to return this dummy skipped assertion node in my abstract syntax tree. But what that means is that I'm reaching the end of this read list block without having read the entire contents of the list. Now, like in this case, that's sort of what I intend to do because it's intentional, because I haven't implemented this thing. But what I'm worried about is, are there places in here where might I have bugs in the future because I've sort of somehow failed to completely consume some part of the input? Because it's fine at the moment, nothing is checking that there aren't leftover elements in the S expression when I finish ostensibly reading this list. And so I think just from a sort of mental model of what's going on point of view, it would help me if I could tell when I'd done that. No, the pattern match doesn't fail, because you can see what's going on here is that we just read. So this is a list, right, that might contain 10 atoms in the S expression. And what we do is we pop the first one off. So read is just going to pop the first one off. And then here there's a pattern match that checks to see like, well, what's the first thing in the list? I've called it opcode here. Is it module or invoke or assert return or one of these assertions? And then there's everything else that's in the list, which unless in here I say until finished, well, if I say like read until finished here, then that will consume everything else in the list and just throw it away. But I'm not doing that. I probably should be. But at the moment, I'm not making any attempt to read what comes after assert malformed or assert trap or whatever. And it just bails. This read list is just going to finish at that point. Oh, wow. 160 subscribers. Thank you, Tyrag. That's good to know. Wow. My million subscriber gold YouTube button I assume they're already starting to carefully pack it in its box, in the assumption that by the time they've posted it and everything, I'll probably have, if you project that line, it's pretty much by the time a package will arrive from California or whatever. Yeah, so hold on, what am I doing? Okay, so I've renamed it to read list. So Joel, just to explain. So Joel's saying, why can't you read each item until the list is empty and handle each type in the pattern matching case statement? Because this list is a single command. It's not multiple commands, it's just the one. And I mean, well, let me see. So here's well, I mean, module's not a very good example because it contains loads of other stuff. But like this is a better example. So this is a single command, right? And you just have to read the first thing in it to find out what kind of thing it is. And then you've got all of the rest of the stuff inside this list to deal with. Now, if it's assert return, my implementation of assert return knows what this looks like. It knows that there's an invoke, and then it knows that there are 0 or more arguments following it. But in the case of assert malformed, assert trap, assert invalid, assert exhaustion, I neither know nor care what arguments they have. So at the moment, I'm just not doing anything, and that just leaves this list incompletely read. And I suppose what I'm saying is that's fine in this specific case because I don't care what the arguments to these things are. So there's no need to even read them from the input because I'm just going to throw them away. But in general, it feels like a good piece of hygiene to make sure that I have read the entire contents of the list. Because if that happens when I wasn't intending it, then that means I've made a mistake. That's what I'm trying to say. So what did I say here? Make read until... Oh, sorry. What? Where was it? Rename with input to read list. Oh, and make read the default argument. Right, that was the other thing. As I noticed that almost everywhere... Well, yeah, almost everywhere... It was just... So let me see where... Okay. So let's make read the default argument. So if you don't provide an S expression, it's just going to read one from the input. And then let's see where is that the case. So it's sort of implicitly the case there. I don't see that command being used anywhere. Oh, in fact, I can just get rid of that, right? So that local variable wasn't being used for anything at all, so it's kind of good that I've got rid of that. Again, here is definition being used. Nope. So this is exactly the kind of thing I'm talking about, is that like I was hammering this away last time just to desperately get the test passing, and I didn't really think very much about what made sense. So this just uses read, so I can just get rid of that. Likewise this. Likewise this. This is a little bit more complicated because I think expression is being used, yeah, down here. So I can't so easily get rid of that one, so I'll just leave that for now. Yes, same deal here. But actually, I think if I reorganize this code, I can change that. So watch this space. So here, that is not being used. So that's fine. That's just using the default. That's just using the default. That's the definition. That is legit. Oh, and these are read until. And that's using that. Okay, that's fine. I'll leave that alone. Okay, so is that all still fine? It does look okay, doesn't it? So let's say here, make read the default argument of AST parser read list. And let's just say it looks like the majority of the call sites are passing in read anyway, so we might as well spare them the trouble and only use the parameter in exceptional circumstances. So now I think I can just say remove read list argument when it's just read. There are a few cases where either we're providing something that's not the same as read, e.g. in parse expression, where we've received a new S expression as an argument, or we're providing read, but we need to keep it in a local variable for some weird reason, e.g. expression in, what was it? Parse function, in the parse function method. It might be possible to refactor around the latter, but I've taken care of all the obvious cases for now. Yeah, Marco, someone's already asked that. James Adam asked the same question. So Marco's asking, is there a reason why you aren't using git commit without any arguments to write the message in detail in one go? I didn't have a particularly good explanation then, and I also don't have a good one now. I think the real explanation is that it's just a habit. Yeah, it's just a habit. I think the reason that that habit has formed is because it... I mean, this justification is more high-minded than it deserves, but if I was going to, write a think piece about this, what I would say is that it gives me an opportunity to focus on the big picture, like what's the subject line of this email that I'm writing, or what's the first line of the commit message. And it's important to me that that stands on its own. So whenever I'm writing the commit message on the command line like this, I want it to be essentially enough. I just want it to be like, this hopefully tells you some combination of what I've done and why. And that's usually all I'm thinking about. So I just want to like bash it out, make the commit. And then there's like this slightly separate mode of thought, which is like, okay, I can relax now because I've made my commit. And if I wanted to, I could just carry on and start working on something else. But now there's a chance for me to take a breath and think like, are there any thoughts rattling around in my head that would benefit from being written down in the commit message? And if yes, then I can use git commit amend to jump in there and then just start free associating in Vim and typing in whatever comes into my mind. But sometimes I don't want to do that. Sometimes I'm like, well, that was just fixing a typo, or it was just a very self-explanatory change. Like when I renamed that method, I was like, well, I've just renamed the method. What more do you want to know? In fact, I did say more then, but sometimes there isn't anything interesting to say. Yeah, exactly. So I could leave it at that without opening it again. And it's more than that. It's like, I think most of my behavioral adaptations are purely for the purpose of just like avoiding having to think about stuff. And so in this case, it's like, I can write the commit message without the thought even entering my mind about whether there's more that I want to say, because I can't at that stage. So it's like a nice constraint that it's like, I've just got to write the subject line of this email that I'm sending to myself in the future. And then I can separately stop and think about whether there's any color or detail that I want to add to it. So it's just, I don't know. It's just a habit that I've built up. I don't really understand why. I'm glad it makes sense to you, but like I said, it's a bit of a post hoc rationalization of just a bit of muscle memory that I've got. Yeah, I don't know. Anyway. So. Oh, yeah. The thing I wanted to try was what happens if in here, if I raise unless S expression in array pattern, is everything still fine? It's looking quite hopeful, isn't it? Okay, well, that's enough for me to... So this is just check that read list is being called with a list. It currently always is, but I want it to fail fast if I ever make a silly mistake and call it with an atom. And I guess the opposite thing is maybe here. I really don't like this begin, because I'm about to raise an exception here, and that's making me think about what are the semantics of ensure blocks. So I think I'm actually going to change this because it's gone a bit silly. Let's just, because the only reason I'm using begin ensure here is as a hacky way to not have to do this, but I think I should just say what I mean. Don't try to be clever. That's never worked out well. So this is where the business happens. And I could put tap on the end of that or whatever, but I think this is fine. So I don't know what fit of pique led me to use begin rescue, begin ensure there, but it was well, it was certainly laziness, but I don't know. I think I thought it looked nice at the time, but as soon as you have to start thinking about exceptions, it's not there for exception purposes, and that's what it strongly suggests. So I think that was a bad idea. Get rid of unnecessary, or let's call it misleading. Begin, ensure, end block in read list. This, so here we go. Now we're in that mode. Makes it look like there's something exotic happening to do with cleaning up after exceptions, but it's not that at all. I was just using ensure as a lazy way to avoid having to store the result of yield in a local variable, and I didn't want to use tap for some reason. Given that I'm making an effort to be clear rather than clever, I think it's far more preferable. I think it's preferable to use the dead simple approach of just assigning to a local variable. Okay. So yes, what I wanted to do here was, and I guess I'll do it here, raise unless S expression self, S expression empty. So that was really why I made that change, was to, because I couldn't decide where to put that thing. But now this is where it should go, is immediately after the yield. And there's not an ensure in the way forcing me to make a decision about whether this raise should go inside the begin part or the ensure part, basically, because now that decision no longer needs to be made because there is no part. Okay, let's run the tests. Okay. Unhandled exception. It was called in parse function, line 155. So again, is this intentional? How can this be the case? So this is definitely not expected behavior. Unhandled exception. So this is happening while it sits in a loop here. It reads expressions off the Oh, right, look, it's because of this. So, right. So, yeah, I mean, this is actually the same problem as I was talking about before, so maybe this is germane. Like, what's happening here is that it reads a complete S expression off of the input, and then it says, okay, let's dive into that S expression and start reading it. And that's what it does in all of these cases. It reads the whole S expression. But when it falls through to this case, because this is the thing that is reading the header of the function, so it's reading any exports, any type definitions, any parameters, any result types, any local variable definitions. But then if we fall through and it's like, oh, this is actually just something that should have been part of the body of the function, we're not reading anything. We had a local variable that already had the expression in it, and so we're just wanging it straight on like that. And I think that's probably not, I mean, it's not a massive problem, but it's also not like, I don't think it's what we should be doing. I think ultimately that local variable should go away. So what do I want to do here instead? Because expression needs to be a list. So what I need to do here is say, if I do this, expression is an empty list. Expression, read into expression until finished. And then put that expression into the body. Yeah, that fixed it, because this is a problem in a different place. So I think that's, I mean, obviously what I could have done here is I could have just said read until finished and not bother saving it anywhere. But I think the fact that I'm saving it into the place that I'm putting it into the body, that now breaks my dependency on this local variable up here. So I could get rid of it in this case. And I think it could also be got rid of down here. So that's a separate change that I'll make in a minute. But for now, I think that's solved that aspect of the problem. Parse command. I mean, that's, to be honest, that's probably this, isn't it? Because that's what I had. It's still to do, but let's make that actually consume the rest of that list. Okay, well, that got a lot further. What else have I forgotten? Parse command. Okay. Why has that happened? Puts S expression inspect, please. No. Float literals. Oh, module binary, right. Yes, of course. So yes, it's this one, isn't it? So I basically just need to do the same thing here. So, I mean, I know this is just, I'm not really fixing any of these problems. I'm just plugging the holes, but I think this is forcing me to make a decision at each point about, like, what actually was it that I needed to do. And I think these have got a to-do comment next to them, so I know that it's just throwing away, tokens. Okay, that's fine. Let's get rid of that now. Okay, so how are we doing? So, I mean, none of those were super surprising, but they were arguably oversights. So, I mean, what I want to get to is a degree of confidence that the parser is reading every single token from the input, every single part of the S expression, even if right now it's ignoring some of those parts because they're types that we don't need, or because they're arguments to unimplemented commands. But it seems like we've got to that point now. So what did I say in my previous message? Check that read list consumes its entire list. If we ever forget to read any of the input, I want read list to fail fast. It turns out we were already doing this in a few places, none of which were particularly surprising, and all, well, no, I was going to say they were all intentional, but they weren't. What that expression one was an accident. So I've just fixed them up as part of this change. Okie doke. All right. So I think that's a positive change. And I think I can check this off now. Make read the default argument. I could have checked that off already. Push all the read your own opcode code inside each parsing method. Yeah, I should do that at some point. Do we really need terminated by? Oh yeah, should there be an expression AST node that's returned from AST parse expression instead of a bare array of instructions? If not, we should get rid of script, since that's basically the same thing for commands. I think since I wrote this, I think I'm coming down more on the side of getting rid of script, because this isn't communicating anything. Like, so there, arguably, so if you're talking about like algebraic data types, right, which is essentially what we're using here, you know, there are different kinds of AST node, right? And they have, the constructors take different arguments and they store different data, and they form different sort of groups of, you know, siblings, basically. Like here, you know, there are, well, at the moment, there are 3 different types of commands, and then this 4th one that's sort of a dummy kind. But these 4, module, invoke, assert return, and skipped assertion, are all siblings. They're all types of command. And in the interpreter, it's gonna, if it's got a big list of those, it's gonna have a case statement that's switching on what type of node have I got. So that's one reason to have, even if they don't have a payload, even if all of the constructors are nullery, they don't have any data inside them, just having 4 different like tags effectively for the 4 different situations you could be in, there's some value in that. Or if there's only one kind of situation you can be in, which is in the case of something like module, where here there's only one kind of module that you can get back when you call parse module, but it packages up a lot of data, and so it's useful to have, even though there's like not multiple variants that can be returned from this, you know, from this method, it's still useful to just have a single kind, because it packages up these 5 different, you know, these 5 different attributes. So it's useful in that case. But I think in this case, this doesn't pass either of those sort of smell tests. Like this is just an array of commands. And when I call parse script, what I should get back is basically an array of commands. And for whatever reason, I think I made a decision in my head that every one of these parse methods was going to return an AST node. And maybe that does make sense. I don't know. It just feels really silly to make to do expression.new here. Instructions. That just feels silly. I think for now, it's not an important decision. For now, I'm just going to go with my gut and say it's not important that all of these methods return AST nodes. If you've got an expression you want to parse, I'm going to give you back an array of instructions. If you've got a script you want to parse, I'm going to give you back an array of commands, because that's what expressions and scripts are just lists of instructions, lists of commands. And there aren't 2 different types of script that you need a different constructor for. And a script isn't structured, interestingly, that means that you need to have 2 or more sort of segregated buckets of stuff. Like, it's just an array. So I think I'm going to be honest about that, and just for now, I'm going to err on the side of simplicity and get rid of that node and say it's not really part of the abstract syntax tree. So it's effectively what I'm saying is you can't get an AST that is an expression. You can't get an AST that is a script. You can only get arrays of those things. And that's fine, because inside the AST, lots of the attributes contain arrays. I mean, that's another reason to not have an expression node, actually. I think maybe let's retroactively pretend that that's my objection, is that there are lots of places, in the function body, we accumulate all of the S expressions that constitute the function body, and then we parse the function body and we get back an array of instructions, and then we just store that as the body here. We don't say, oh, and we're going to make an expression node to hold that. And I mean, maybe we should. And if I wanted to do a style of interpreter where it was like the way that evaluation proceeds is that you send an evaluate message to the root node, and then that sends evaluate messages to all of its child nodes, and so on, then maybe I would need to introduce an expression node in order to make that work. Although it really just depends on what's the implementation of evaluate on function, right? It can take care of the fact that body contains an array of instructions. But anyway, it's going to be less work for me if I just allow these to be plain arrays, or if I allow expressions to be plain arrays. And so I don't see why I shouldn't also allow scripts to be plain arrays. So that's my long-winded and not very convincing explanation of that decision. So that here we get back an AST, which it isn't really. I'll call this commands. I'll call it script. Let's call this script. That makes it a bit less confusing. Def evaluate script. I can't type. Oh, the argument's already called script, so that's nice. And then here, instead of script.commands each, we just say script each. Do command. And that seems fine to me. So sorry, that was a lot of words out of my mouth for very few, in fact, really only deletions in the code. But let's say get rid of script AST node. Do I have anything I want to say about that? See, Marco, I'm now playing up to this claim that I actually do some thinking at this point. Yeah, let's just say, well, here's the truth of it. At the moment, an expression is represented everywhere as just an array of instructions. So for now, let's allow a script to be represented as just an array of commands. If this turns out to be a mistake for any regularity-related reason, we can easily change it back the other way and make both things AST nodes. But at least this way, it's both simple and consistent. Okay. Tick. All right. So I think what I would like to do now is, rather than be completely at the mercy of my checklist there, is just allow myself to spend a little bit of time with this file. Because, like I said, as I've been scrolling through it, I have a very strong suspicion that there's tons of stuff in it that could easily be, tons of patterns that could easily be extracted. And I mean, I'm looking at one right now and finding it hard to not be distracted by the fact that this is a very common pattern. So let's say if I could say def, let's call it repeatedly, and that started with an empty array, call it results, and then it yields and just shovels whatever that does. Oh, but there needs to be a loop, doesn't there? results yield until finished is what I was thinking. For some reason I was thinking like, oh, this is the thing that you would yield to, parse command until finish, but that's not how any of this works. So that would allow this to become repeatedly parse command, which I rather like. Certainly easier to visually understand than what I had there before. Does that work? It sure looks like it does. Okay, well I think until finished is going to be the giveaway for the ability to use that. So this becomes repeatedly read. And I mean, that is going to accumulate the results into an array, which I then discard. But I think that's a temporary state of affairs, because at some stage I'm going to want to implement these things, at which point I'm either going to need to replace this with something more forensic than just read everything into one big array. Or in some of these cases, I might just want the big array, but then I'll have to assign it to something and do something with it. But for now, that seems fine. It's looking good. Okay, here's another repeatedly read. So that's very nice. This is until finished. I mean, I guess that I can use it here too. This is just repeatedly do. And again, I'm not actually... Because this doesn't return a sort of heterogeneous collection of all of these things, it actually shovels them into different local variables depending on the type of thing, which, as previously discussed, may or may not be the right way to go about this. Read list is just going to return... I don't know what it returns. I don't care what it returns. And that's going to be accumulated into an array here, then that's going to be thrown away. But I think that's fine. Yeah, I think the benefit of regularizing this outweighs the sort of, performance overhead of shoveling stuff into an array that then becomes, it's dead essentially. It doesn't go anywhere. I mean, on a long enough time scale, the static analysis performed by MRI is going to spot that value doesn't go anywhere, and it's just going to elide those instructions and say this doesn't need to happen. So I think that's a completely justifiable reason for me to just do stuff like this when it's convenient for me, and then wait for MRI or YJIT or whatever to catch up and, get better at optimizing my code. Okay, look, this is exactly it. So this can become expected equals repeatedly do this block, and then there's no shoveling needed here anymore. I was going to say I could inline this read, but this needs it. I won't get distracted by that for now. I would really like to be able to inline all of these reads rather than have this business, but I will, this is what Sandy calls horizontal refactoring. And the first time I heard her say that, I think it made me quite angry because I didn't understand what it meant. And then I said to her, what's horizontal refactoring? What are you talking about? But it turned out what she meant was go in a straight line from where you are to where you want to get to, and don't get all distracted by, in her sort of spatial metaphor, it was like, don't wiggle up and down, just go all the way across and get to where you're going. I mean, maybe it's not just a metaphor, maybe she is talking about literally refactoring a single line of code, but I still think of that idea when I'm trying to stay focused. It's like, I'm on the left-hand side and my target is on the right-hand side, and I want to just go horizontally and not, not forget what I was trying to do, which this explanation has made me forget what I was trying to do. So thank you very much to all of you whose fault that is. Okay. So this is just repeatedly do. Throw away the result, that's fine. We've just had that conversation. This is just repeatedly do. So really, I mean, I could separate these into one that returns a result, and I could have called it collect or something, and one that doesn't return its result. But like I say, I think I'm quite comfortable with the idea that I can just be lazy and accumulate the results anyway, and then if they get thrown away, then so be it. What's going on here? Shovel onto results, read until finished. Well, taking that at face value, what that's saying is that I need to repeatedly read, and then whatever I get from that needs to be concatenated onto results. Is that right? Yes. So if this read A, B, and C, then I should have shoveled A, B, and C onto the end of results. It's not an array that I'm putting on the end of it. It's a splattered array, effectively. Okay, it's been a while since I ran the test, so let's just... I'm just blithely mucking around in the file here without even checking to see whether I've broken anything. Okay, well, that's pretty convincing. Okay, I'll leave that running, but let's see. Until finished. Okay. Right, so this is repeatedly do. This is repeatedly do. It's a shame there's this read in here. Like, what's that reading? Oh, it's reading the parameter name, which we're then ignoring. Oh no, it's the type. It's the parameter type. I mean, it occurs to me that this... No, I guess I'll leave this alone. What I was going to say was that this could be repeatedly read and then we could map over it. I'm just gonna leave that for now because I'm just trying to get this repeatedly do in, and then maybe there's a separate improvement I can do that's looking for patterns of usage of where the last thing that you're doing repeatedly is shoveling onto something. I mean, that is a pretty strong indication that we should be... Yeah. Okay, look, I'm just going to get rid of all of these until finished, and then I'm going to come back and next thing I'm going to do is think about these repeatedly do blocks. So again, this is results concat repeatedly read, I think. Here we go, same deal. Oh, look, here we go. Yeah, great. So this is... Okay, brilliant. So this expression here is just repeatedly read. That's much better. Okay, so yeah, now actually I didn't need to worry about that collision of the expression local variable because you don't even need one. I could just inline that. Again, there's a bit of hubris creeping in there because I haven't actually seen the test pass, but I think it made sense in my head, and that's really the main thing when it comes to computers. You know, you may choose to run the program if you insist. Oh, interesting. So this is doing the same thing, but it's accumulating into a string rather than into an array. There's a temptation to inject this because it's the same method being called on it, but I think I'm going to resist that temptation and just use the interface I've already got. And then I can always change my mind later. So this is string equals repeatedly parse string would have been quicker to type it, and then joining them, because that's the same as in a loop appending the result of parse string onto the empty string. So I think that's right. I might as well just leave these tests continuously running because any one of these could be a silly mistake. Okay, unless finished, elements. Okay, this is interesting because obviously at the moment I'm reassigning a local variable here. But elements is initially empty. So if this becomes repeatedly read, then that is actually the value of elements that we want in this case. And I mean, I could say elements equals, but then we're already doing an assignment to elements up here. So I think what I would rather do is use the fact that read list. Oh, I was saying I don't care what read list returns, but of course I do care. It returns the value of the block. That's the whole point of my silly dance here with the ensure and stuff like that. So the fact that read list returns this repeatedly value means that I can just make elements be if finished, empty list, else do this. And in fact, do I even need the conditional anymore? Because surely if we've already finished, then this is just going to yield to the block 0 times and return the empty array. So I sort of believe that I can get rid of the tests aren't reading this. Well, actually they will if I save it, because I forgot that the way this works is that it spins up a fresh instance of the Ruby interpreter for every one of these. So actually, if I save this, it will have an effect. But this fits my mental model of how this is working, is that I think because of mathematics, it just does the right thing, because of monoids or whatever, you just get the right behavior. You don't have to, you don't need that conditional. Okay, it's looking healthy so far, although parse table is actually quite obscure. I can't remember what test uses that. It's like stack.wast or something. Oh, shit. Yes, I was right. It is. Okay, all right. What's going on? Okay. Well, maybe all that rubbish I said is not true. So hold on. It's because of that assertion I put in, isn't it? That unhandled exception on line 352 is going to be the check that there's actually a list to read. Oh, that's not where the assertion was. It says line 352 in read list. Whatever. That's line 352. Oh, is it because I've... Yeah, it's because I edited the length of the program, wasn't it? Okay, 356. I forgot how line numbers work. Yeah, so it's like... So I think everything I said was true, essentially. But unfortunately, I've deliberately set it up so that you can't call read list if there's no list to read. So I guess that while I could make it work... Oh no, that's not... What I said isn't true, is it? Basically, I'm wrong about this, because repeatedly read is not the only thing that we do. We also are forced to read this LM business. So it's not legitimate to do what I was doing. If that wasn't there and it was just like, well, if there's a list, then repeatedly read it, then I think what I said would have been more legit. But as it is, I don't know. It was just all nonsense, wasn't it? I was just talking rubbish. Let's face it. I can live with that. Okay, is this actually what I was searching for? I don't think so. Until finished. Oh, look! It's exactly this. Repeatedly do. Oh, no. Not so simple. Rubbish. Okay, so... Right. So parse folded instruction returns an array, and parse instructions, and parse instruction returns a single instruction. So... I think the right thing to do here, get rid of this expression local, and just return the thing. But for this one, return... So from both, lowest common denominator, both of these branches return an array. And then that's fine. Repeatedly do. No underscore. What is wrong with my brain? And then this needs to be flattened once, because we effectively want to concatenate all of these arrays that are returned have to be concatenated together. And I think it's probably fine to flatten them without the 1. I think that's probably okay. Well, let's see if any of this is okay. But I think that's right, because obviously in the case we've only got a single instruction, that can't be a nested array. It's just the single element array that we've just made. And in the other case, unfolding should never return a nested array. This parse folded instruction should always return a flat array. So I don't think there's any important difference between allowing it to be recursively flattened all the way versus specifying only 1 level deep. But I'm going to specify 1 level deep. This is a bit of a bugbear for me in Ruby, because I really like it that that flatmap does that by default. So in flatmap, you can do A, B, C. That's one array. And then you can say E. And then you can just say flatmap itself or whatever. And it flattens it 1 level. It doesn't try to fully flatten it. And I really like that, because that's essentially what I want here, is that flattening. So, I mean, I guess I could do literally what I've just said here. I could just say flatmap itself, but that feels weird and unnecessary. Like all of those message sends just to get the same value back. I mean, flatten is designed to be essentially the identity, but with flattening, whereas flatmap is designed to map, obviously. It's designed to change the contents of arrays, which I don't actually want to do here. So I think this is probably the most expressive thing that I can write, but it's just a bit annoying that I have to... I wish there was just a method you could call that just did this, that did flatten 1, but I don't think there is. No. Oh well, we can dream. Okay, and now we're back. Okay, so now this is actually the only occurrence of the finished method, so that's rather nice. So now I think this should probably go down here with all of this low-level mucking about stuff. So what is this? Extract AST parser repeatedly helper. Helps if you... There's a little Git tip. To make a commit, try first staging your changes and then making a commit. You will find that you have more success that way. Do I have anything to say about this? It turns out we're repeating this pattern all over the place. So it's helpful to wrap it up and give it a name. In some cases, we don't care about the result of the block, and we just throw the accumulated array away. I'm comfortable with the performance cost of doing that, since it's clearer. I think this is true, since it makes the code clearer than having two separate helpers, one which collects the values and one which doesn't. I think that's true. I mean, there is some clarity in being fully explicit about your intentions, but in this case, I think saying that we want to do something repeatedly and knowing that the results of doing so are always available to us if we want them, but as with everything else in Ruby, if you don't want it, you just don't assign it to anything, is completely idiomatic, so it doesn't really bother me. Okay, well that was satisfying. I'm glad that we've got repeatedly. Now, are there any places where I can get away with inlining this? So I'm just thinking about this expected. What's going on here? Is this the same as if I get rid of this and this just becomes peak? So I haven't actually read it from the input yet. Obviously here I need to read it now, because otherwise I haven't read it on this branch. But on this branch, could this just be read list parse expression? Because I'd rather do that. Oh, so right now this is calling parse expression that takes an argument, but it should be calling parse instructions, which just uses the current S expression. Right. That's better. This actually shouldn't have been calling parse expression in the first place, but it just fell out that way. Okay, I think that's better. I want to do something about this as well. I don't really want to be in a situation... I'm not sure what my justification for this is, but I'm also not sure I can be bothered to give one. I don't like being in this situation where I'm matching a whole S expression against some pattern. What I want to do, the whole unifying principle of this parser is that it's consuming one atom at a time. And doing this sort of breaks that constraint. And again, doesn't have any practical impact really. Well, I suppose the practical upshot is that if and when I decide that I want to get rid of the S-expression parser and just have like an S-expression tokenizer that is just feeding a flat array of tokens, or I mean, ultimately it'd be nice if it was an enumerator of tokens into this AST parser, then it will make that transition much easier if I have that regularity I'm talking about. If everything is done by just peeking one token ahead and making a decision on the basis of that, and maybe we need more look ahead than that, but whatever, then that transition will be much easier. So that's like a concrete benefit of organizing it in that way. But there's also the sort of intangible benefit of I just want it to work the same everywhere so that I don't have to think about what's going on. And that's been my motivation for all of these changes really, is just to get this into a shape where I don't have to remember that some things do a weird thing. I just want everything to be extremely mechanical and regular. And at the moment, this is like the fact that we're matching a whole S expression rather than chomping through it one item at a time is like a bit offensive to that principle. But I won't mess with that just yet. Yeah, I was looking for, sorry, I'm not being very articulate. I was looking for opportunities to inline. Right, so here we can just inline it. No one cares what your opcode is, mate. So I guess it's cases that I'm looking for. There we go, we've inlined it there. No one cares about your opcode, mate. Let's just read. And this, to this point, push all the read your own opcode code inside each parsing method, e.g. read invoke should be inside parse invoke, not its caller. So, I mean, that was up here, I think. Oh, I've got the wrong window is focused. Here I'm reading invoke before I call parse invoke, but really parse invoke should be the thing that's reading that. So all of these reads should really be peaks, but that's another consistency argument that like it should be the same everywhere. It shouldn't be this weird mixture of sometimes you're peaking and other times you're reading. It should just be one thing. But again, for now, I'm just going to tolerate. I'm going to stay horizontal and just fix the thing I'm trying to fix. So that's inline case read. Oh, this is the expression thing. Okay, well, I think the only person who cares about expression anymore is read list. Right. So if I hadn't done this, if I hadn't read it and this was just peak, then this would just become read list, right? Because then expression is just the next thing that you read. So this is much nicer. I would much rather have it this way, and it's a case peak, which is what I want, rather than a case read. But I've just got this pesky expression down here, but I think I must be able to get rid of that. I just have to think about... So we're looking to see what's going on here is that when you're reading the body, when you're reading a function definition, up front, there are a load of these annoying special things that aren't in any way demarcated from the... Oh, this is a terrible example. Let's look at float extras. So there's all the boring header gunge. After the func keyword, you've got like export, param, result, blah, 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 blah. And then, well, this is actually not a good example. I know what is a good example is my friend and yours, tau. So this has got like all the gunge. Here's a list. That's a special thing. It's an export. So that's what this conditional is for, is if we're about to read a list, then it could be one of these interesting, well, one of these boring ones, essentially. An export, a param, a result, some local variables. Now, the problem is that if it's it's a function like this, then after we run off the end of these, now we're just into the body of the function. And so that's what this case down here is for, is, oh, if it's actually not a result or a local or whatever, then it must just be some instructions. So please just repeatedly read those instructions. But there's also this other case where we found something that's not a list at all. This is just, or at least it's not a nested list, it's just a flat sequence of instructions. And that's what this case is for. So what we need to do here is, I think, is this just body is read? Yeah, because in this case, we've gone inside a list, and so we need to read the whole thing. Whereas in this case, we've just found we found f64.const, and we just want to add that onto the body. So I think that's correct. It took a suspiciously long time. But it is getting there, so that's fine. So so now, oh, look, we do need opcode here because all of these have to flip in read it. Right, and again, the problem is that, well, why can't this just be case read then? Well, I'll tell you why. It's because of this final case. Because in this final case, we hadn't found one of these special instructions. It was just a generic instruction, in which case we need all of the tokens for that, including the first one, because they're all part of the instruction. So there's a structural problem here. It's lopsided. This needs to be redesigned so that we don't even enter this bit unless we know we've already got one of these things. I'll come back to that. I think we need some kind of predicate that allows to... Firstly, we need a predicate that allows us to detect this case. So, like, can I read a list? And then given that, maybe you need to be able to ask, can I read a list that starts with export or type or whatever? Because if I could ask that question, then I wouldn't even have to enter this conditional if I knew that I was going to fall through to this final case. And in that case, I could just unconditionally read the first item because I know it's one of these things because I've already like guarded the code to check that that's what's going to happen. What was I doing? Inlining. Yeah, I was looking for case. Yes, so I'm sort of complaining that I can't inline that, basically. I mean, no, I'm just going to leave that one. That one already is inline, very nice. This is unrelated. And case peak. Yeah, now we're into, this is all fine. We have to read the opcode here because we have to pre-process it before we're ready to do this case, so that's all fine. And then this is not the code I wrote in a fugue state on the previous stream, so I'm loath to mess with that, really. Although it's not impossible that there's stuff in here that could benefit from what I'm writing up there. In fact, I can see, yeah, there's all sorts of, repeatedly stuff down here. I think what I'm going to do is focus my attention on the fugue state output. Am I? I mean, I am interested in this stuff. Does anyone care about this opcode? I mean, it looks like I am going to look at all of this. Oh, interesting. So in those... Oh, yeah, look. Oh, no, that's read until. Oh, hold on. Read until could use repeatedly. Okay, I'll come back to that. Okay, so look, actually here, it's only these first two cases that need to know the opcode. So I think this is what I was resisting the temptation to do in that other case, was like just wang this, binding it to a local variable in every single pattern match. But it's actually only these two that need it, because they have to look up the opcode in this lookup table to find out what class to call the constructor on, whereas all the rest of this stuff will quite happily not. Yeah, I'm not happy with all this code here. Okay, there's lots of potential cleanup to do there, but I think I've done all my inlining. Let's just let the test run once more. Call, read, or peek directly in a case where possible. Should have listened to my own Git tip there. Okay, all right. Well, that's done a bit of cleaning up, hasn't it? But oh. So what about read until? Well, so I've got a couple of opinions about this. One of them is, I don't think, if you look at all of these places where I've seen read until, I've had a sort of a visceral, unpleasant reaction to this keyword argument, because it's really adding no value. Because this already says, it's already called read until. And so the additional information that you're getting from this single required keyword it's just not helping. It's clear from until that this is the thing that is gonna terminate it. So I think I'm just gonna get rid of that. Because I don't like it. So if I change this to be like terminator, and then this is just terminator, and then everywhere I'm saying terminated by, I just get rid of it. I think that's gonna remove a load of syntactic noise. I mean, actually, it turns out I don't call it very often. So let's just say, what's the best way to explain that? Make read untils terminated by argument a positional argument. Well, I don't repeat argument. The keyword is too verbose and doesn't clarify anything. Clarify my typing. Okay. Okay, but then the further thought I had was the code that I would like to be able to write here is something like, if we get rid of this tap and loop business, then it feels like Terminator, basically. Like, I want this to... I want it to not have this condition, where in fact that whole thing, I just want to say, until we reach the Terminator, read an opcode. And I know this seems algebraically like it's broken because we don't check for it to be finished until after we've read this opcode, and then a bunch more stuff happens. But in practice, the bunch more stuff that happens would not have happened if this had been a finish, because if we've read an opcode here that is one of these, block, loop, or if, I mean, this was actually sort of wrong, because this made it possible to have one of these structured instruction opcodes that was like the last thing in a list, and that would have quite happily terminated. So actually, this previous behavior was not quite right, whereas this new one is quite right. So what I want to do here, atoms, shovel the opcode on, and then if it's in this, concat, and then shovel. So I think the way that I would think about this is to have a conditional here where the else case is, so we're going to get rid of atoms altogether. The else case is we're just returning an array that is just the opcode, which is what this case was. And in this one, we're returning an array that's got atoms, opcode, and then read until end, splatted, because that was being passed to concat, so we're not preserving the array structure, we're just adding everything in this into the same array, and then just end. So I think that's great, and the only problem that I can think of with it is that it's not going to work because repeatedly doesn't have an until doesn't have an until argument. But if it did, that would be great. Hold on, what's this? This atoms opcode business is not at all right. So I think this would work if only repeatedly had this behavior. So let's see if we can arrange that. So I can't have a keyword argument called until. How much do I care about this? I do care enough because that method is called read until. I want to be able to say repeatedly until. And I guess I could make another version. I could make another method that has this behavior, but I'm going to make it an optional keyword argument instead. So here we can say terminator equals quargs until. I can't use fetch there because it's optional. So now we say, hold on, I've got to think about this. So if you provide a terminator, I mean, I'm starting to have doubts about this, but the current behavior in read until is that the terminator gets read and thrown away. Like the previous code that we had here would, if what you had found here was the terminator, it's already been read from the input. We haven't peaked, we've actually consumed it, and then it doesn't go anywhere. We only stick it onto the resulting atoms if it wasn't the terminator. So we have to, for now at least, although I think this is probably not the thing that we're ultimately going to want to do, because I've become more skeptical about it over time since I implemented it. But given the current behavior, I think we have to do something here where it's like, I think at the end of this block, we're going to have to consume it. We're going to say, we're going to read, and then I'm just going to say, read it into whatever the value of the terminator is. So this will raise an exception if it doesn't match. Well, okay, I'm getting ahead of myself because we don't know why So we've got a loop here. We're going to do this until finish. But now I guess what I'm saying is, or peak in terminator. Like if the next thing, we can't read it here because we don't know what yield is going to do. So I think this is right. We should look to see if the next thing would be the terminator and stop if it is going to be that. And that's why we have to read it at the end here. I think that's right. But then we need to make sure that we only try to read the terminator if that is why the loop finished. And I suppose the easiest way is to ask, well, did we finish? If we've run out of atoms to read, then we obviously don't need to do this, because that's not, we didn't terminate the loop because we saw the terminator. But if we finished for this other reason, then we do need to read it. Oh, and we need to make sure that when you don't pass in until, so if this is like terminator is not nil, and so I think there's two changes here. One of them is sort of adding this until functionality to repeatedly. And then the other one is using it inside read until. Let's see what I've broken. Oh, unfortunately, the answer is the syntax of my Ruby program. 569 syntax error. Oh, well, that's just I forgot to put a comma. Worse errors have been made. I think that would have been more obvious if I'd put it on one line like that. Okay, try again. Okay, this is looking... I think if I'd completely screwed that up, it would have been more of a bloodbath than that. So, two separate changes here. Add support for optional until argument in repeatedly. Is that right? Yes. I'm adding this so that I can use it in read until, which is about to become, oh crap, what's gone wrong? Okay, hold on, I've done something bad. What have I done that's bad? Float expras. Well, so much for my... It would have blown up by now if something was bad. Theory. Okay, so what's changed in the semantics of this? Repeatedly until terminator do. If opcode, read the opcode. If it's in block, loop, or if, opcode read until end, end, else opcode. Oh, it's the same. Right. Sorry. In my translation here, I overlooked that we're in this flattening situation again. What we get back from this is supposed to be a flat list of atoms. And in my haste to get rid of this shoveling stuff and say like, oh, I can just pack them into arrays like this, I forgot that it needs to be flattened at the end. So again, I think the result of this whole repeatedly needs to be flatten one. Which test was failing? Float expressions. Okay, that's right. This is why static type systems exist. It's to stop programmers doing this kind of, making this kind of silly mistake. Okay. Well, I will allow this to run and hopefully it will finish this time. I nearly knocked my water over there. That was a terrifying moment. I do not think my laptop would run any faster if I did that. Maybe temporarily. Okay. Great. Okay, so now what? I mean, do we really need terminated by? Can read until always just. Yeah, I don't know what the answer to this is. When we do read until. I think that by definition, yeah, I mean, maybe that's why I checked this off. I think we do need it. Like, when you've got a flat list of instructions, you have to know where to stop when you're parsing. It's structured instructions that cause the problem. The problem is finding how much you want. Can read until just always just do that for you rather than baking this feature into parse instructions. I don't know what I'm talking about here. I must have written this in a delirious state. Yeah, I mean, that's just nonsense. Sorry. Make read until automatically stop. Make read until automatically stop when they reach finished. Is that actually correct? Well, that is now what it is doing, because now that it's implemented in terms of repeatedly, it's not mandatory that it hits the terminator. I mean, I guess I could change that, but at the moment it seems fine. Is that actually correct? It might hide syntax errors. I think this is another reason. So my answer to this is that, well, I've done it. I think it might hide syntax errors, but the reason is because we throw away the terminator. I think maybe it would be more hygienic for the caller, even though I did it this way to make stuff specifically less hassle. I think now... See, I think it's a bit of a... I think it was the choice was made to make this code easier, but I think that was, I mean, temporarily it was what I needed, but overall I think that was sort of a mistake. I think we should probably, so you can see here we're essentially reading this body S expression many different times here, and it's unnecessary. We should just read it the once. So I think that decision was made to paper over an error. And I think if I make it so that read until and repeatedly, don't discard the terminator, and read it and force the caller to read it explicitly, because it's the caller's problem. If the terminator's not there, the caller needs to try to read it, and then that will provoke a syntax error. If they've reached the end of the input rather than find the thing they were looking for, the caller needs to try to read it and then blow up. And because of the discipline I've put in place about saying you have to consume the entire contents of the list that you're reading, I think that will sort of dovetail nicely. So if you want to read something structured like block or loop or if else end, then it's your job. You can say read until end and it will do so, and then it's your job to read the end in case it wasn't there for some reason, and indeed so that you are completely consuming what you were supposed to be consuming. So I think that is the right thing to do. But again, is that the most bang I could get for my buck here? I mean, parse structured instruction is in a right state, isn't it? Let's just look through these and look for things to be upset about. I mean, basically, what I want is for every one of these to just be completely obviously correct with no weird stuff going on in them. And at the moment, there's still quite a lot of weird stuff going on. Although I think these top few are exemplary. Parse commands is just repeatedly parse command, which is exactly what you would expect. I mean, that's barely pulling its weight as a method, really. Parse command says we're going to read a list and then we're going to do all this stuff. And that involves, by the time you reach the end of that stuff, you will have read the whole list. That's good. Parse module, I think, is similarly probably about as good as it's going to get. I mean, I could extract this. This is like read definition or something. But I think extracting things into smaller methods is like something that I can do once. If it's just to purely decompose large things into smaller things, if there's no sharing benefit, I can take that or leave it and just do it later once everything's all tidied up. This is very nice. Assert return. Yeah, so expecteds repeatedly do case peak. And then, yeah, I'm a little bit unhappy about this. Well, firstly, I think this, if I'm going to do anything, I think this read, these local variables should be assigned when we've read them. And at the moment, we haven't read them yet. So again, just like from a discipline point of view, I think we should be forced to read them there. But apart from that, I think that's rather nice. I'm basically 100% confident that that's working. Oh, hold on. I haven't committed that change. I'm being premature. What is this? Use repeatedly in read until. I don't know what else to say about that. So this is just bind local variables after reading, not peeking, in parse assert return. This doesn't matter to the computer, but I think it's important. But I think it makes the whole implementation easier to understand when we only use information that we have, well, we only use values that we have officially read, not ones that we've only peeked at. Okay, so that's just more sort of regularity concern, I suppose. Is there anything I can do? So this is a good example, right? We peek at it and then we read. I wonder if I could do something about this shoveling. So is there a way I could rewrite this? Because I can see that we're in a situation here where, like I said, I think this could be rewritten as repeatedly read. And then we just ignore we're not interested. This is read here is just getting the type, and we're not interested in it. So this can return an array of parameters. This one can return a single parameter. And here, this could be parameters.concat. This conditional, essentially. Does that work? I mean, is that an improvement? It would be if I extracted the body here. If this was like parse parameters, which, as I said, I'm sort of assuming I'm going to want to do. This one is results concat something. This one is slightly more complicated. I'm pretty sure that result should also have a similar kind of structure there, even though it's slightly different because it doesn't have the name. In fact, yeah, result is getting away with murder there, isn't it? Because we don't even have an AST node for it. I think I do prefer this situation where so I realize this is a little bit more fiddly, and it's this conditional inside these brackets is not very nice, but But I think I prefer just having one place where we modify the value of parameters, and then all of the detail here is just about, well, what do we add on to the parameters then, rather than have this cropping up in multiple places that you then have to find. I think this is a better separation of concerns. There is just a concatenation onto parameters happening, and then what gets concatenated is a separate question. And like I say, that makes it very easy to just extract this. So I think I prefer that. So let's say use concat in parse type to add more parameters. What else do I want to do? I'm a little bit frightened of this parse function situation because it feels a bit out of control. So maybe I should try to sort of beat this into some kind of smooth surface rather than have it be a total mess. Okay, well, look. It's silly that this whole opcode situation is silly. So I think what we should actually do here is make this case peak in export or type or param or result or local. And then inside there, we can have case read because we know that we can. So basically it becomes this. So this becomes case read. And then we can get rid of all of these read in the opcode because we know that we've already done that. What's that peak opcode? Oh, I think that's left over. So I think that's what I'm talking about. I'm saying like, we look at what the next thing is. If it's one of these opcodes, then we read it and then we switch on it to decide what to do. If it's not one of those opcodes, then we do this repeatedly read business. I think that's a bit less grotty. It doesn't totally solve the problem that we have here, which is that this whole thing is a bit lopsided. Really, there shouldn't be two different ways that we accumulate into the body here. We should be able to spot when we've finished reading these function header shenanigans, and then we should just flip straight into a slurp up the entire rest of the function body mode. But we're not currently in a situation where we can do that. So what is this? So this is like unconditionally read opcode in parse function once we know it's special, basically. Oh. Yeah, and I don't think I'm going to say any more about that. I'm just going to let that go. Parse memory, basically fine. Actually, here's a bit of an anti-pattern. Like when we've got an assignment at the end of a read list. Let's see, does that crop up anywhere else? See, look there, the assignment is already outside of the read list. Here it's outside of the read list. Here we don't care. That's all about side effects. There we don't care. Here it's outside. So actually this is perhaps the only place where this is happening. So it's really, the result of reading this list is that we get the string. And then I think that means that we can get rid of that equals nil, because now this is outside of this block. It's got the right lexical scope, whereas previously that we had to do that fake assigning to nil to make the local variable have the right scope. So that's a win, I think. See, that's outside, that's outside. This is assigning two different things, so fair enough, although I think we can probably do those separately. What about repeatedly? Because that also has a return value. No, I don't think that suffers from the same problem. Okay, cool. So this is assign string outside of read list block in parse memory. Let's say as a bonus, this puts it in the correct scope, so we no longer need to initialize it to nil just to make it available later. Okay, that's good. So this is all just sort of boring stuff, I suppose. I've already done the inlining of the reading the opcode here. Here we have to read it first because there's all of this other junk to do before we even get on to trying to read the body of the instruction, so that's sort of unavoidable, I think. Structured instruction, part of normal instruction. I mean, I realize that this is not particularly gripping. I'm just sort of combing back and forth through this and looking for fights that I can pick. That results in parse structured function. Structured instruction, sorry. So here where we've got if peak in result, right, well, so I guess this is an example of somewhere where, like I said, we're sort of reading into a pattern match here. What I want is to say results equals, I want to lift this assignment up, right? So in this case, it's easy. I can just say empty list. But for this, it's a little bit more difficult. But I think if instead of read into this list, if I make this a read list do, then what I can do here is just read into result. And then the splat results there just becomes repeatedly read. And then that's the return value of that block. And so then that goes into results there. So I think that's sort of the kind of thing that I would like to do in more places. Did I make any other changes? No, just that. So I wonder if I can do a sort of audit of places where that's happening. I mean, yeah, like I'm not particularly happy with this, but like I say, if I had a helper that could do this, it's more the reading that concerns me, and then the peaking is something that we can deal with separately. So is it like read in? I guess it's read has to be in. Right. So how would this look? If instead of reading into this pattern, I mean, same transformation as before, what I'd say is that I was doing read list do, and then all of this junk is the business of reading the list. So I'd read into this pattern first to get the instruction, and then I'd read into that pattern to get the nan. And I mean, I'm still doing this up here, but I think in terms of the reading, now I'm more explicitly saying, let's go into a list, let's consume the whole thing one atom at a time, and then, do the thing that we want to do. Actually, the bits can be figured out up there, can't they? So we've read the instruction, we figure out the bits, then we read the nan, and now we've got everything we need to make that nan expectation. That makes sense to me. Okay. So where else? I suppose that's fine. I mean, that's just checking that it is. I mean, really, this whole thing could just be unfold read, couldn't it? I don't think that's adding much. I think I could just do that. Yeah, I think I'm going to do that. I don't think that enforcing that it was a, unfold is going to enforce that. So I don't think having that fail fast I don't think it was failing any faster than it otherwise would have. Let's just say inline read in parse folded instruction. And I'll just say, I don't think that matching against an array pattern was adding anything here, because unfold already requires an array argument and will fail fast if it gets anything else. Yeah, it was just that I committed. Okay, so this is about my vendetta against. Right, so there's loads of these, aren't there? Call indirect. Parse normal instruction. What about... I'm not very happy with this business. Maybe I can come back to that, because it's not really an instance of the problem that I'm concerned with, but this is... Well, I'm gonna think about this while I'm here. So this is a big mess. This is just about, well, not so much this bit. I don't feel so offended by this bit, but it's more this sort of... Well, I do a little bit. Like, this is a repeatedly read situation, right? Like, this reads one index because there has to be at least one, and then it puts that in an array, and then it's sort of accumulating more of them. But I would really like this to just be indexes equals something. And actually, I think I'm overreaching here in the parser by enforcing that there's at least one of these. I think I should allow myself to just... Basically, I think it should have been like this. It's not the parser's problem if you don't provide... I mean, you know, arguably it's a syntax error. But it's the kind of thing that validation would catch, rather than something that the parser should have to worry about, I think. Even though I'm sure the grammar says that there has to be at least one here. In fact, I know that it does. But I think in terms of keeping this implementation simple... Oh, I don't know. Maybe it should bail out if you haven't provided at least one of these indexes here. BR table takes, like, var args. So the problem here is that we don't know how many arguments it's taking. It's just however many numbers appear after it. So it will just consume all of the numbers that appear after it. So what I want to do here is sort of... The simple thing to do is to say, like, repeatedly, you know, until not a number... That's not valid Ruby yet, but if I did that, then I'd be able to just say, well, I guess just this. What I've called index here could be peak. If peak starts with... Oh, hold on, it doesn't have to be a number, it can also be a... Yeah, it has to be an index. So it can be a number or an ID. So if it starts with $, then we just return it, we just read it. And if it starts... Well, if it's anything else, let's say not an index. So this is a bit weird, right? But I'm saying the terminator is something that's not syntactically an index. If it starts with $, then that's fine, we'll just read it. Otherwise, we'll read it and turn it into an integer. And then this is fine because this is just saying we're gonna split that up. We're gonna pop off the last one and make it the default index. Like I don't care about this. This isn't the input. This is a different array that I've made. But how's not an index going to work? I can't think of a great way to do that. It's a bit difficult to make a regular expression, because remember, this until is going to ultimately become is ultimately going to live here, right? So it doesn't have to be a literal string. It could be, for example, a regular expression. You can write a regular expression that says this is not something that starts with $, and it's not a number, but it's not very beautiful because I think you have to use negative look ahead assertions again, which have already been a little bit unpleasant. I mean, what you can do is pass in a proc and say that some regular expression doesn't match the argument. So I could do something like this and say repeatedly until, well, what would this look like? Oh, I guess it's this. I mean, if I just pulled my finger out and extracted this regex, this, I don't think this would look so bad. Does this even work? Seems to work a little bit, doesn't it? I might as well add this. I know I said I wasn't going to get distracted by stuff, but it turns out I have been. Yeah, I think that's better. Use repeatedly to read BR index, BR table indexes. And I'll say, we're now no longer enforcing the presence of at least one index. So that'll have to be checked by validation. I think that's okay. In order to make this, I mean, obviously this isn't beautiful, but I think being able to just boil that code down into repeatedly read a thing that's either this thing needs to, if I can make this appear in several places, then this itself can become a helper that's like, I guess it's read. What's it called? Index? Yeah, and then look, that's the whole thing reappears here. So yeah, I think having the ability to read an index, or maybe it's parse index, I don't know. Yeah, I mean, I've said parse integer. So maybe this is just parse index. Yeah, that's fair enough, isn't it? It looks at the content of it. Yeah, I'm annoyingly, I'm sort of halfway through. Maybe it's okay if I stash this. I mean, there's all these. God, there's so many problems to look at here. Okay, sorry, I'm gonna ignore extracting that helper for now. I'll add it to the list. Extract a parse index helper. I will get around to that, but just not right now. Because I wanted to continue horizontally. Because there's a bit of a mess going on here with the assignment to table index. I can see that this can just come out of this conditional entirely. So hold on, what was the class of changes that I was making before? Oh, it was the array, replacing array patterns with read list, essentially. So this isn't that. This is just like, right. So there are some array patterns here. So maybe I'll commit this, and then I can get my teeth into those array patterns that are right underneath it. So this is something like move table index assignment out of conditional in parse normal instruction. Okay, so now we've got all of these. We've got several of these. We've got all three of these. Oh, in fact, these two are loops, right? So, okay, this first one. So ultimately, the goal of this is to get the type index. Okay, so let's break this apart and say if peek in. So if we're looking at a list that begins with type, then we're going to do this thing, but we're going to do it with read list. So this is going to be read list do, and then we read type, and then we read this thing. And then that gives us our type index, right? So that's given us, we're still peeking. Again, I suppose what I'm trying to do here is create this situation in as many places as possible, because if all we're ever doing is peeking, and you can see we're doing it here already. So this is a sort of regularizing constraint that if we're just like, if the only question we're asking is, could we read an array that begins with type or that begins with param, that's sort of creating the opportunity for us to have some kind of helper predicate that tells us that. So if peek in type read list, it's a while loop. We don't really have a good way. I can't say repeatedly or anything, because the match is sort of more complicated. But I can at least turn this into read list do, read into param, and then, oh, it was splat, so that's repeatedly read. And then I think the same thing is true here, but it's just with result. So that sort of exploded all of the, oh God, look, they just keep coming. I think this is the last, that select is the last case there. So this just becomes, but again, there's a, well, in fact, it's exactly the same as that. You can see in those cases we're not actually using the value, we're just silently consuming them. And at some point in the future, we're presumably going to have to care about all of that stuff. So why is this call indirect? Right, yeah, we're not going to be able to get away with ignoring these for that much longer, because they affect the stack when we do an indirect call. Oh dear. Okay, what have I done wrong? Okay, hold on. What have I done right? Okay, so it's float expros that's complaining. Okay, so that's fine. So I'm just incrementally adding bits of these back so that I don't have to think. Okay, that's fine. Okay, so I'm going to make a work in progress commit here. What is this commit doing? It's something like use read list instead of matching list patterns. I'm not going to bother. Like, all of these commits have got essentially the same justification, which is that I'm trying to regularize and sort of clean up and make everything the same in this parser, so I'm not going to re-explain that every time. Okay, well, okay, one of these is bad. Oh, I just blithely copied and pasted this, but actually this one is sort of optional, it's conditional. So it needs to, what I did here needs to go inside this. I can't just, so I think that's it. I think that's what I overlooked. Yes. Okay, that makes sense. I want to tackle this thing that I was complaining about, where there's lots of read until end here. And there doesn't need to be. So I think what I can do here is, well, in fact, it's not just this, it's also the consuming the label that appears after the end. Like, I think I can do all of this. So it's, if I do all of this up here and say before anything, because we're going to do it in all three of these cases, so we might as well do it once here. And then here, this is body S expression. And this is body S expression. Well, let's try float expres because that's pretty punishing. So yeah, I think that's the right thing to do, is just read that straight away. So, I mean, this is degenerating into sort of general cleanup, but you can see that basically this is essentially exactly the same as this. Oh, hold on, and sorry, I forgot. I mean, this code is now harmless because it's never gonna, that condition is never gonna be true. Peak is never gonna match the label because we've already consumed it. But that was unnecessary. So now these are even smaller. And you know, there's really quite a strong temptation here to just combine these. Oh, also, look, I mean, at the moment, I'm assigning the result of this. I guess this is another stylistic thing. At the moment, I'm assigning the result of read list to body, and then I'm using it here. But I could just do the whole thing inside, like that. And I think that's nicer, actually, because it's got less, you know, weird indentation going on. And it sort of says more plainly that what we're doing is reading the list and then so hold on, I'm just thinking about what the granularity of my commits should be here, because I'm already disappearing off down a rabbit hole. So maybe that is a meaningful commit, right? So this is like, what do I want to say? Read body S expression first in parse structured instruction. And then I'll just say we need it for all three body, loop, if cases anyway, so we might as well just read it once up front. Okay, and then the next thing I did was move these in fact, can I do a similar thing with this? Because this is the same deal, isn't it? That can just go inside the block, and then I don't need these, and I don't need to initialize those things to nil because they get assigned inside the block. So that's good, I think. Let me just check if. Oh, is if one of the ones that I still haven't implemented? I keep thinking that if is one of the ones that should be passing, but yeah, it's not. It needs block type with parameters. I think this should be a high priority one to fix next. And I think these should be high priority so that I get the import spec test thing working. Okay. Well, then it doesn't matter what if says, because float expres is passing. Oh, in fact, look, now that I've done this, this whole thing can go inside read body, read list body S expression, because all three of these is just the same now. Or they've all got that around it. So if I just see, this is exactly the kind of thing that I want to happen. Oh, hold on. This is actually a little bit magical. So I think I can do the whole thing like that. Get rid of all of these nested read list body S expression things. And then I think I can move this afterwards. Oh, but then I've lost the return value. Yeah, this is like result equals. Oh, maybe in this case I will do it with a tap, because this is just like consuming the label afterwards. And the reason I'm doing that is so I can just inline this. That seems way nicer to me. So we've got a... I think the nature of this is that we could have a flat list of instructions that's being fed to us here. So we can't just read willy-nilly. We've got to read until end. Right, read list doesn't have a notion of until. Okay, hold on. Does this work? Yes. So this is, I think what's happening here is that we're getting more of the actual structure of the instruction that we're reading is sort of bubbling up into the structure of the code that we're writing to parse it, which is exactly what I want. Like there's a nested operation here, which is reading the body of the structured instruction. And then you have to do this little fiddly bit on the ends to optionally read a trailing label. But that's fine. So we read the opcode, we read the leading label if it's there, and then we do this sort of optional result thing. Yeah, I think I really like this. Again, I'll just double check that hasn't broken anything, but I think this is a good improvement. So this is something like move read until around well, let's say move all body parsing code inside a single read until read list block. Yeah, I think that's good. I like that. And then the thing that I was going to do, but now I'm not sure I can be bothered, was sort of combine these two and then have that sort of dispatch on look up the class in a hash type thing. But this is now so simple, I'm not sure it's worth it. I think I'm sort of happy to live and let live with that now. I think doesn't really bother me. So I think this is the thing I'd like to think about next. Make it so that read until don't discard the terminator, because now I could just discard the terminator here. It's no big deal. There's only one big with else as well, fair enough. But these are literally the only two places that even care. Repeatedly. I'm actually a little bit worried about this because I think this is... I'm actually surprised this hasn't broken anything, because presumably this is... Whatever it is that causes this to terminate, is it not throwing it away? So how on earth is this working? Like, I think I sort of forgot that repeatedly throws away the terminator. Yeah, I mean, it's not really read until that does it, it's repeatedly. Oh, and here, this read until, so I think this is a perfect example where it's like read until end, and then we've had to tack on an artificial end here because read until has thrown it away. Whereas really what we want is for this to be read, And these should be peaks. Okay, all right. Hold on. Let's do this. I realize that's... So this is inline read in... Well, let's do that. Read in, read until. I'm now no longer sure what my system is for when something's in backticks and when it isn't, but now's not the right time to get distracted by that. Okay, so that's chugging along. Okay, yeah, I wanted to get rid of the... I wanted to stop discarding the terminator, basically. So let's imagine that read until didn't throw away the terminator. So when this says read list, read until end, I'm not suggesting that it includes that in the contents of the list, because I think that would be really painful. But at this point, I think we could just read the end and then read the label. And then I think it makes this code easier to understand, because it's like, well, what's this chunk of code doing here? Oh, it's reading the end with an optional label. And actually, again, there could be a helper method there that's like, that does that. So I think that's okay. Here, read until else. Okay, so this is the reason I'm grimacing is because this is a little bit fiddly, because this is a case where the else is actually optional. It won't necessarily be there. So now we're relying upon and I guess we were previously, relying on our ability to run off the end without finding this, and it'll just terminate anyway. But that means that we need to be careful about assuming that, you know, because this else is optional, it won't necessarily be the next. It won't necessarily be the next thing. So, I mean, let's say unless finished. Well, is that clear, or is it clearer to say if peak in else? Is that clearer? Because then essentially we do all of this. We read the else, we read the label, and then we assign the alternative. Yeah, it's like if the, yeah, I think that probably is clearer, right? Because you've got this nice symmetry. And it's the same, albeit, yeah, if only this was, yeah, I've got some ideas. We need a pair of helpers here. We need one thing that says, could we read a list that starts with result? And then there needs to be a thing that says, do read a list that starts with result, that just takes care of throwing that away. Because at the moment we're having to sort of, and again, maybe, you know, well, this is actually fairly concise as it is, but there could be helpers that do these two things. If can read else, then read else. rather than having to write these conditions ourselves. But I think that's... Oh, yeah, of course it's not going to work because I've... Yeah, sorry. I don't know what I was thinking. These are all speculative changes of what I would have to do if I made this change. So read until end, we would have to read the end. Read until else. Excuse me. So actually, I think I think this is clearly way better because actually being able to detect the presence of this else and use it to decide whether we're going to read the alternative is really good. I really like that. So that's cool, actually. That's given us sort of a superpower that we didn't have before. And then, yeah, this is the final remaining use of read until. And then here, as I said, this just changes to read. So we read the opcode. We read, and so the opcode being block, loop, or if. We read the start of the structured instruction. We read up until end, and then we read the end of the structured instruction. And I've just realized that this should probably account for the trailing label because that is part of the structured instruction. Account for trailing label correctly in read until, e.g. Here we go, the chat spam has started up. Loop, foo, end, foo. That's what I'm talking about. Okay, so there's a bit of an oversight there, which doesn't appear to have been a problem until now, but I think this should, the whole point of this is to skip over a structured instruction, and actually we've forgotten to skip over the trailing label, so that's not very #principled, is it? So those are the three places. You know, previously I was like, oh, woe is me, we have to consume it because if we don't, then it's a huge amount of busy work. But now I think, now that this has been hammered into a nicely structured form, it turns out that here I think it clarifies what we're trying to do, and here it actually makes, well, it also clarifies it. Like, neither of these feels like a chore. It feels like it's actually good that we're here, we are forcing ourselves to read an end, and here we are checking to see if there is an else, and if there is, it triggers the parsing of the alternative. So that's great. However, read until isn't actually responsible for this, it's repeatedly. So repeatedly until terminator. I mean, is it just that? Could it be that simple? Yeah, I guess so. Okay, great. So this is don't discard terminator in, well, read until and repeatedly. This means the caller has to take care of discarding the terminator, but that's an improvement because A, it makes the code more explicit, and B, we can in the if else case, we can directly check for the presence of else when deciding whether to try to parse the alternative. Okay, that's good. Okay. I'm fairly happy with that. So that's this. I think I'm going to do this, push all the read your own opcode, blah, blah. Let's do that. So, okay, where does this start happening? Parse command. That means that this isn't going to read it. It's just going to peek it. And that means inside parse module, parse invoke, and parse assert return, it's now our job. So here we have to read module. Here we have to read invoke. And here we have to read assert return. Do any of these have any other callers though? Nope. Oh yes, there is one here. Oh, but that's okay because look, we just don't do that. And then this can just be that. And then what about parse assert return? No, I don't think anyone else calls that. Okay, great. Okay, I'll let the test run. This is not the whole change, but I'm confident that those things are probably fine. You can hear the confidence in my voice as I say that. Okay. So now down to the next level of the tree. Here we go, parse function, parse memory, parse table, parse global, parse goal. So again, this change this to peak, and then we have to parse function. That needs to read func, and that's the only caller. Parse memory, how the test doing? Good. That needs to read memory, and that's the only caller. Parse table, that needs to read table, and that's the only caller. Parse global, that needs to read global, and that's the only caller. And then parse type. Oh, hello Marco. I just realized I don't actually get what read into end is doing. I mean, I know it's a rightward assignment, but where is it going to assign its return value to? A string variable named end? Or is that the way if you want to use reserved keywords as variable names? No, it's misleading. I'm sorry. So what is going on there is... Hold on, let me just finish this last one and then I'll explain. So this is a pattern match, right? I mean, I understand why you're calling it rightward assignment, but Ruby doesn't really have rightward assignment. It just has single line pattern matching. So I mean, obviously, if it's a variable pattern, then it works like rightward assignment because you're saying I want to match this pattern, which is just a variable pattern, against whatever value comes out of calling read. So what I'm doing here, this is essentially documentation, right? It doesn't well, it's documentation and it's sort of belt and suspenders fail fast stuff, because what this is saying is essentially it's the same as read, but it also means match it against this pattern. And so if the thing that I've read doesn't match that pattern, it's going to raise an exception. So just like here, I'm reading through this regular expression to make sure. I mean, I might end up deleting a lot of this once I'm confident that the parser is actually working correctly. But at this point, it's just a way for me when I'm reading this code to see, like, if this was just read, it's a little bit anonymous. It's like, well, what am I reading here? And it could be like raise unless read is equal to type. But that's what this does. And so this is just a sort of a more compact way of saying the same thing, basically. And yeah, I agree. It is confusing if you're not familiar with it. And, you know, I found this stuff confusing before, and now I think I'm so submerged in it that this is just what programming looks like to me now. Yeah, I mean, I think once this is all working, I think I said to you before that like part of my motivation here is to sort of force myself to get comfortable with these new bits of syntax in Ruby 3.1 and 3.2. Yeah, the pattern match, you get a, you know, if I try to do this, foo matches bar, it'll just say no matching pattern error. So yeah, it's the pattern match itself that returns the exception, and you just get nil otherwise. Once I've got all this working, I think I am going to have to make a sort of a global decision about, like, you know, given that one of my stated goals here is clarity, I am going to have to think about these things and say, like, you know, is it, because what I could do, you know, an alternative to this could be that I could give read an argument, right? So I could make it so that if I want to read something and check it, I could pass that in as an argument, and then it could, that raise unless, you know, the value that I'm reading in is equal to a thing could be built into the read method, and perhaps that would be clearer than having this sort of pattern matching. No, I mean, I suppose the thing you were missing is the existence of single line pattern matching, right? Like there are two different syntaxes for single line matching, and one of them is this sort of, you know, foo in foo or bar or baz, and that returns true or false depending on whether the pattern matches or not, right? So this is like a Boolean predicate that just returns true or false to tell you whether the pattern has succeeded. But if you replace in with that kind of hash rocket or rightward assignment or whatever you want to call it, now it returns nil if the pattern matches, and if the pattern doesn't match, it raises an exception. So it's kind of like, you know, like in active record in Rails, you've got like save and save bang, and, you know, one of them raises an exception and the other one doesn't. It's kind of like that. Like you've got either you can ask a question as like a predicate and get a Boolean back, or you can just do a pattern match, and then the side effect of that is that it will raise an exception if it doesn't match. And of course, the usual side effect of a pattern match is that you get any bound variables get matched. So in here, I could say like, in fact, I think that's maybe not syntactically valid. But you know, if I was matching like 1, 2, 3, and then I match that into first, comma splat, then I get nil back. No exception is raised, but also it has assigned that local variable because of this variable pattern in the first position has matched the 1. So yeah, there's actually quite a lot of choice about how to deploy these. It's not just inside case, it's also in this kind of single line thing. Yeah. Okay, well, you are agreeing with me, so that's good. All right, how far did I get? Parse type. Okay, so far, all of these things are reading with this potentially confusing syntax. You know, here we're reading a func. So I think as long as I'm inside, I think it's fine for me to have case read here because I'm in control. It's when I'm handing off control to another parse method that I don't want to have already read that first thing. So parse type, parse function. Yeah, I don't have any helper methods in here. Maybe I should. So we read memory. That all looks okay. Parse table, parse global. Yeah, I guess that was it. I think I've done it. So I'll just say, what is this? Push opcode read inside parse methods. Yeah, and the tests are all passing. So there we go. Cool. Well, that wasn't too bad. I thought it might be worse than that. Okay, this stream is getting rather long, but I just want to keep chipping away at this until I have no more will to live. Because I feel like I know that a lot of this is still quite hard to read, but I think it is incrementally getting better. And I think the reason why it's getting better is because I'm imposing this sort of disciplined, nested structure on the code that didn't previously exist there. So I think as I'm gently pushing on all of these issues, it is starting to yield a little bit and get a little bit more maintainable. I don't like this still. Okay, I think because I don't like this, I think I'm gonna chip away at this issue of reading lists. Like, I don't like this. I don't really want to write that. I want to write something like if can read list. And then, oh yeah, and like I said, there are probably opportunities where there's like an optional argument here that's like starting with and then read list starting with. Not here, but in other places, I know that that's definitely a thing that I want to be able to do. And here's another one. If can read list, then read list. And again, this should really be like starting with data. Well, I'll add that later, but I think there's potential for that. And where was that thing where I did? Yeah, this, because that's what I'm asking finished here, but that's not really what I mean. It has the same effect, but what I really mean here is if, well, I need to invert the sense of this conditional. I need this to be if can read list, then do this, else it's the empty list, right? And I think that makes more sense than asking whether I've finished. Because really, ideally, I was going to say the only place we would ask that question is inside repeatedly. And that's almost true. But here we have to... I guess what I could do here is repeatedly read. And then I would have an array with either one or two things in it. So maybe that's not a big deal. So where else do I have this sort of... Oh, I have to escape everything. Here's one. If can read list. I know I haven't implemented this yet. Right, raise unless s expression in. I guess this should be raise unless can read list, basically. Like, have I actually checked this? yeah, there's no more instances of that pattern. So with my little helpers down here, let's make can read list live down here, and that is just going to be, again, here we go. So this is not inside a case, but this is just a one-line pattern match. Is the next thing that I read going to match, this is like a pattern that matches any array, right? And I could also do a type comparison here, which is ultimately what this is going to do under the hood, but whatever. I'm going to use a pattern match for that. So I think that's, oh no. Okay, what have I missed? Case peak in star, case peak in star. If can read list, case peak in star. Oh, hold on. I can't use, I was wrong. I can't, yeah, okay. Because this doesn't read. Yeah, I don't know how to explain that, but can read list is going to peak, whereas actually I just want to use this expression that I've already been given. So someone somewhere has to allow an S expression to be injected in, and the whole point of this method is to reassign the parser state to be that S expression. So I think I just have to live with this. And this isn't doing anything. This isn't load bearing. This is just a fail fast thing that I can remove afterwards. It's not, it's just, and like this, it's just so that I don't, so that I know about it if I screw up. So I think this is extract can read list helper. So that's nice. There were definitely a couple of places where I wanted this to have an argument, right? So not there, but I think here, I think I want to say of can read list. I think I said starting with data. That's kind of what I want to say, and then that matches this, and then I think I'm going to want to give this a read list starting with data, but I'll do that later. This thing here is starting with LM, because that's the only situation in which this is okay. So where else do we have this sort of, I feel like there was some stuff in past structured instruction where I was, yeah, look, I knew I'd forgotten about that. So here, this if peak in blah should become if can read list starting with result. And I think this nicely captures the idea that we're in this language, we're only ever looking at the first thing. If at all, we're only looking at the first thing in the list in order to make a decision, because that is where the instruction name lives, what I've been calling the opcode. So it has a privileged position. It's not just the same as every other item in the list. It's actually special, and I think this sort of reveals that quite nicely. So where else do I have this kind of peak in? I wasn't looking for this before, but yeah, all of these. So this is if can read list starting with type. This is while can read list starting with param. And then this is the same deal but with result. So yeah, I don't yet have a nice looping construct that can work here. But I mean, maybe that repeatedly do is because it is just until finished. Maybe it's not really adding anything in those cases. Maybe I should save it for these cases where I do care about the return value. Let me say that here. Should I only use repeatedly when I care about the return value? Until finished is not much worse. So yeah, I'm going to think about that. Okay, so we've dealt with all of those. Oh look, there's more here. If can read list starting with result. Okay, so having hypothesized that change, I now need to implement it, starting with. So if starting with is nil, then we just do what we used to do. Otherwise, I suppose, peek in, and it's variable pinning here, starting with, because if I don't pin this, then this will assign to starting with, which is the opposite of what I want. Ah, thank you, Marco. I've missed a few question marks. All right, yeah, if I've typed can read list a few times, I probably have forgotten to put a question mark on the end of it a few times. Yes, well spotted, thank you. It was actually just that one time, but that is enough for it to blow up. Okay. Missing keyword starting with, okay, well, I need to make this optional. It's a very good point, Ruby. Yes, once. Okay, this is looking good. So what is this change? I don't want your advice, Get. So this is like add starting with argument to can read list. And then, yeah, I think part of the payoff of doing this is so that I can balance it out with I mean, I sort of want to add, the problem is it's already got so I want to add a keyword argument to this. I think I'm a little bit uncomfortable actually looking through these calls of read list. I don't feel great about, you know, I ended up removing that terminated by keyword argument in a play to read until, because it didn't feel like it was adding anything. I feel like I've got the opposite problem here, which is that most of the time we call read list on its own, and it's talking about reading a list, right? And it reads it from the same place as when you just call read. And so that makes complete sense. But it feels like when you put this argument in here, you're sort of changing where you're reading from. And I don't know that that's completely clear. So I think what I'm going to do, just bear with me a second here. I think I'm going to make this argument into a keyword argument. I think I'm going to call it from, and it's going to default to just doing a normal read. But then all the places where I'm calling read list, well, this should be simple. Replace read list bracket with read list from. Yes, read list from S expression, read list from body, not there. That's the definition. Yeah. And mainly what I'm doing here is to make room for another keyword argument, which I don't think should really be any less important than this thing, because this is just this is not, you know, for it to be the only positional argument, it was like, this is very important, but I don't think it is very important. It's orthogonal to the other thing, which is starting with. That's what I want to add. And you could either have both or only one or neither. And I think keyword arguments are ideal for that kind of situation. Great. What have I done? Oh, here's what I've done. I renamed that. I renamed the argument without renaming it. I have to be a little bit cautious here because S expression appears many times. No, no, yes. That's it. Okay, how about now? Okay, that's looking a bit healthier, isn't it? Convert read list positional argument to from keyword. That seems to be fine now. Okay, so having done that, I think that makes the space I need. Yes, I think now I can. Okay, the tests are happy. So if I had starting with here, then where would I get the benefit of that? So what I'm talking about here is when we've asked, in situations where we've asked whether we can read a list starting with something, then it feels like here I should be able to say read the list starting with that thing, and then I don't need to read it in there, so it sort of goes away. I mean, maybe what I should be looking for here is the occurrences of can read list. Well, let's see. Where are all the calls where I could make use of this? Here's one. I mean, apparently this is reading a list starting with mut for mutable. I haven't documented what this is. I guess this is probably a type. Most of the places where I'm just reading something and then ignoring it are just types. So there we're not. So here we go. Here's another one. Here's one where we don't know what it's starting with. or at least not concretely. It's one of those three things, but I don't support that. And we already read it up there. Yeah, okay. Again, here we don't know what it's starting with. All of these we do. And I mean, there's obviously a lot of repetition involved here, and I wonder whether there's a way that we can wrap this up. You know, this is like maybe read list or something that can sort of just gracefully return nil, which is what this does. So yeah, looking for... I'm sort of happy to introduce this kind of repetition if it means that there's a chance of more patterns surfacing in this code. So, oh, of course, I haven't actually implemented this. So once again, I've let my imagination run away with me. So how does this work? Well, I suppose I need to read into pinned starting with, unless starting with is nil. Yeah, and then that'll raise an exception. Maybe I could use tap here. I think this is starting to get a little bit difficult to understand. I mean, for me, tap would make that easier to understand, but again, not if you don't use tap. Okay. All right, I'm starting to get pretty sleepy now. We've reached the 6-hour mark, but but I can feel myself making progress here. Okay, what have I done wrong? Read list starting with data, yes. Oh, look, I forgot to remove this. Silly. In fact, I've probably done that in loads of places. Yes. Of course, the whole point of this is to remove these. Okay, I did remember to get rid of that one. I think this is starting to get rather nice now, because a lot of that boilerplate is kind of evaporating. Okay, well, let's make this commit. Add starting with to read list. You see that as it gets later, my commit messages get more terse. I think perhaps there is a benefit to doing this. I think that actually more tidily organizes the code here. It sort of shows you the three parts. It's like check and use the from argument, check and use the starting with argument, do the thing, and doing the thing means yielding to the block and then doing this cleanup. I think I like that better. It looks, previously it was a bit unstructured, and now I think I quite like this. Use tap in read list. And then I'm just going to say, I now find this easier to read because we've got two arguments and we have to handle them separately. And now it's easier to see what happens next. That's a little bit vague, but that's how I feel. Okay. I feel like sort of starting to wind down slightly here. So this is all nice. Feels nice. Module feels nice. This is all certainly much improved from before. Oh yeah, I don't really like this. Well, okay. So, all right. So this should be read list starting with whatever the opcode is here. So let's say opcode equals these. Oops. So if one of those, if we can read a list starting with it, so this is going to tell us okay, it's too indented. The line's a bit long. Let's call it float opcode because that's specifically the deal. So if float opcode is nil, then we do this. So we can't read this thing. Else, read list starting with the float opcode. And then that goes away. This becomes float opcode. It should never have been called instruction. That was always the wrong name for it. Oh, I've just realized this is... Okay. This is okay. But the difficulty here is that the next thing may or may not be one of these weird NaN things. Like this whole thing is very awkward, but it's awkward because this is not an expression that this is not a real instruction that I can parse. It's like a fake instruction. So I think this needs to be, once I've figured out how many bits it is, what I need to do is say, in fact, I can figure out the bits outside of the read list, can't I? So if I read the list starting with the float opcode, then I can say if peak in this thing, oops. did that wrong. So if the next thing that we're going to read is one of those two things, then we can do this and read into the nan, in which case we should return a nan expectation. But that is not necessarily the case. We don't need this else. So now I think I have to do the work. I think I have to say, you know, const.new, you know, this is like what you get. You know, it's this, parse float. This is what you get if it's a real const. So I think I have to sort of slightly repeat myself here. You know, this is like the number. And then this is what you get. So here you either get a nan expectation or you get a real float. And I've just had to do the work here to parse it because I can't lean on parse numeric instruction because this isn't a real numeric instruction, or at least I didn't know it was until I saw that it wasn't, by which time I've already read the float opcode, and so I just have to paste in a tiny bit of the implementation here. All of this is only necessary. Parse assert return is not part of WebAssembly. This is just part of executing a test script. So I sort of feel okay about that. It's not going to be a... what did I think I was doing? That is not valid Ruby syntax. I wanted it to be an array. Type. Well, that's just float, right? Yeah. So I'm just going to have to say that explicitly. I've read the bits by slicing them out of the opcode, and I've parsed in the number. So I think that is a legit undefined expression each for const type float. Why are you calling each on me? Oh, because this returns an array of instructions, right? So I'm not supposed to be returning a single instruction. I'm supposed to be returning an array of them. Yeah, I was misled by this. But again, this is just fake. Or, well, not fake so much. It's that this needs to be evaluated. When it's non-fake, like this is essentially, this thing here is just like a pattern that happens to match. This is like an assertion or an expectation, I guess is what I've called this. This is an expectation that the result of evaluating the actual thing is going to be a canonical or an arithmetic nan. Whereas normally you could put an arbitrary expression in here which would turn into, you know, it could be a folded expression that's going to unfold into 100 instructions. So you're supposed to return a list of instructions, i.e. an expression, which are then going to be evaluated over in the interpreter. So for this to work, I have to return an array here. That makes sense. Okay, that is looking hopeful so far. I will not prejudge it. But essentially, what am I doing here? What I'm doing is, what does that change and why am I making it? I'm making it because I want to read atoms one at a time. I don't want to ever be doing this. I want to just read the first one, make a decision about what to do, and then read the next one, and then cope with the situation. I might realize that I've kind of, I've gone down this control flow path and I didn't want to. Well, tough luck. You've gone down it now, and I have to just handle it. So, okay, yeah, that's all good. So let's just say read atoms one at a time in parse assert return. Okay, that feels good, I think. Um, so the only other things I thought while I was scrolling up and down through this, well, I thought two things. One of them was that I think I can... Where was it? It was one of those... Oh, it was the function body. The function body. So, like I said, let me find the example again. So in a sort of what I consider to be a normal function where the whole body is just a big folded expression like this with brackets around it, we end up using this path to read it. We repeatedly read, yes. So we've gone inside the list, we found that it's a list, we've gone inside it in the hope that it would be export or param or whatever, but it's not, it's one of these guys. And so we just repeatedly read all of the contents of that and whack them onto the body. Is that right? As I say that, it doesn't seem right. I mean, I guess it must be. Oh, yeah. Yeah, I'm suddenly having a moment of doubt about that, but I guess that is right. Oh, this puts them in an array, right? So we repeatedly, that's what I was confused about. We repeatedly read them, and then it's the array that gets that, right. It's not that we're repeatedly, but here, okay, right, yeah. We collect them all up into an array, so the contents of this whole instruction become an array, and then we stick that array onto the end of the body, which is correct, because that is one S expression. So we're sort of scooping out the contents and then putting them in a wrapper, and then that goes onto the body. But here, when we're in this situation, we've just found something that's not a list, because this conditional here is can read list now. If can read list, then read list, else do this thing. And this thing is, we're going to read f64.const, and then we're going to read this thing, and then we're going to read this thing, and then we're going to read this thing. Once we get into this state, I don't think there's any point going around this outer loop anymore, because I think everything that we find is part of the function body until we're finished, until we reach the closing parenthesis there. So I think here we can just say repeatedly. Is that right? Is that right? It's only float expro that's going to tell us. Yeah, that's okay. But then I feel like it's a wasted opportunity, because repeatedly will accumulate the value of these reads. So we can let it accumulate it, and then we can just concatenate onto the body. I think that's perhaps better, because whenever there's shoveling happening inside the body of repeatedly, it looks a bit weird. It was this one that I meant to run, but why not run all of them? Push the boat out. Okay. So let's just say read the whole rest of the function body when we can. That's looking okay. Right, so okay, this is the last thing, and then I'm going to wrap this stream up, because it's nearly 2:30. I would like to avoid this lopsided situation. I would really like that. Um, okay, I think I can use the same technique that I used here, right? Float opcode equals blah. So I think here I can say yeah, let's say opcode equals export type param result local. Sorry, this is getting very messy, but I want to detect, can I read a list starting with that? Can I? Because if I can, well, okay. If opcode nil, then let's take the else case, this. So now, I think that's interesting because it means that this... So here we go. We read list starting with opcode. Yeah, this is interesting because essentially this repeatedly is allowing us to... What the only thing that we're doing repeatedly is trying to find these special things at the beginning of the function, right? So if we're down here, then we've definitely found a special thing. So we don't need this case peak anymore. And in fact, that won't work anymore because we've already consumed it inside read list. And so we don't need this else case anymore. So I think this has flattened out the problem that I was concerned about. It's like, these are the special opcodes that can appear at the beginning of a function. So if we've got one of those, then we say read list starting with opcode. Oh, and then this becomes case opcode because we've consumed it. But I think that's fine because we've already got it in a local variable. And now we've only got 4 or 5 cases there with no else clause. So this becomes our complete, you know, read the rest of the... In fact, that's the whole body now. So actually this is very exciting because it means that... Oh, yes, this is exactly what I wanted. Okay, this is great because this was very troubling. That we had to do this in lots of separate pieces. You know, here, look, we're starting out with the body being an empty array, and then we're doing this sort of weird concatenating onto it. But actually, this is the body now. So I don't need to concatenate it anymore. That is the whole body. Repeatedly read. Hold on. So I don't need to even use read list here. I think I can just do parse instructions. Is that right? Essentially what I'm saying is all remaining instructions, like all of these gymnastics, we're just hoovering up all remaining instructions. So now I think, I mean, this is amazing if this is right, but I think it must be. I think that's just saying once we've run out of exports and params and results and locals and whatever, then just go nuts, hoover up everything else. That's the body. I mean, that is way nicer than what I was doing before. Please work. Oh, it looks like it does. I mean, that... I'm very happy about that. I've just got goosebumps because I'm just extremely surprised that... Well, I shouldn't be. But I'm just extremely surprised that something satisfying ended up happening. Like, I was really just moving the food around on my plate here without much of an expectation that anything interesting was going to happen. But that's actually really cool that I was able to go from piecemeal assembling that list of instructions to just suddenly being in a situation where I can say, right, you found the body, now just go for it. That's really nice. I don't think I ever would have spotted the opportunity to do that if I didn't have these little composable pieces. You know, to spot that this is the same as just body equals read instructions is like a little bit non-trivial. I mean, I know it's obvious in hindsight, but I didn't have hindsight. I was trying to do it with foresight because of the direction that time goes in. So that's really great. I'm just extremely relieved that that worked out that way. I mean, looking through this code, ignoring unfold for the moment, I can see that there are lots of other opportunities for cleaning up and, you know, extracting helpers and giving names to things that deserve names. I mean, this isn't great. I don't like that very much, but I think and yeah, a lot of repetition down here. But I think, like, as long as most of the grimness can sort of be contained, I mean, it just feels like this is a lot better than it was. I know it's taken me a long time of refactoring. Have I done any of the other stuff here? I have not at least begun to introduce an identifier context. Sorry, me. Haven't accounted for trailing label. Haven't introduced a nice module object. I mean, I've checked off, I was going to say more than half. I don't think that's true, but some of the things on this list. So I'm happy for that to form plan for the next stream. Yeah, I feel like I have a better time when I actually do think about this before I finish. Like, implement the spec test module, yes. Think about the trailing label, extract parse index helper, and probably loads of other ones. Introduce a nice module object in the interpreter. Should I use repeatedly when I care? Yeah, I think that is a good plan for the next stream, actually. That is what I should do. So what on earth have I done here? Ignore all space. So what should I say? Stop reading. Let's say only read lists from function body when we know they have special, when we know they're part of its signature. I'm going to call it signature. This is fairly easy now that we have can read list starting with I find it incredibly satisfying that we can now say body equals parse instructions. This is possible because we only need to repeatedly read the lists in the signature, and as soon as we can tell we've finished doing that, the entire rest of the current S expression is just the body. This is so much nicer than what we were doing before to piece together the parts of the body before parsing it. I'm extremely happy that it works. Why not? Okay. I think that I'm going to wrap it there. 46 commits and 6.5 hours in. Let's do the traditional offering to GitHub. Okay. Let's see it pass. I mean, I'm in trouble if it doesn't pass, because I gotta go to sleep. Come on, GitHub. You can do it. This test suite really is taking longer and longer. I think maybe I do have to think a little bit about performance. Well, I tried to think a little bit about performance, but, you know, without much success, it turns out. It does seem like I've made it go a lot slower. Yay. It's passing. So that's something to think about. Anyway. Thank you, Marco, for your celebratory confetti emoji. Right, well, I think that means it's the end. Well, goodness, I'm sleepy now. I can't even operate this software. Okay, well, yeah, I'm going to wrap it up there. Very unusually, Marco, you're in the chat at the end. Usually, whatever people joined at the beginning have long since left by the end. So yeah, you have a good one too. Thank you very much for hanging in there with me while I slog through that not particularly interesting refactor. But I'm feeling a lot better about that code now. I'm actually feeling quite excited about the next time I get to work on this, and the next time, you know, I feel like I've cleared a lot of the path. I can take a run up at the next thing. I don't have all of this baggage weighing me down. It's actually a very nice feeling to have dealt with some of that. So, yeah, both if you're watching live right now, or if you're just someone who's watching this on YouTube, thank you very much for your attention as always. I'm gonna go to sleep now, so I will say, oh no, why didn't that work? Come on, work. It won't even let me say bye. That's so tragic. Anyway, the point is, bye. I'll see you next time.